a select collection of valuable and curious arts and interesting experiments, by unknown. Waterproof gilding and silvering, the art of burnish gilding, ornamental bronze gilding. 1. Waterproof gilding and silvering. This kind of gilding, usually termed oil gilding, being the cheapest and most durable, is in general use for gilding or silvering letters on signs, labels, etc., and may be performed as follows. Grind 1 ounce of white lead and 2 ounces of litharge, very fine, in a gill of old linseed oil, and if convenient, add nearly 1/4 of a gill of old copal varnish, and half an ounce of stone, yellow. But neither of these last are very essential ingredients. Expose this composition to the rays of the sun for a week or more in a broad, open vessel, observing, however, to keep it free from dust. Then pour off the finest part, and dilute it with as much spirits of turpentine as will make it work freely with a brush or camel-hair pencil. Oil that will answer exceedingly well for this purpose may sometimes be collected from the top of oil paints that have been long standing, and may be used directly without being exposed to the sun as directed above. Whatever letters or figures you would gild must be first drawn or painted with this sizing, the ground having been previously painted and varnished. And when the sizing is so dry as to be hard, but yet remains slightly adhesive or sticky, lay on gold or silver leaves smoothly over the whole, pressing them down gently with a soft ball of cotton. The most convenient manner of performing this is to lay the leaves of gold or silver first on a piece of deerskin or glove leather, and cut them into pieces of a convenient size by drawing a smooth, not sharp-edged knife over them. Then take a small block of wood of a triangular form, about 1/2 inch thick and 2 inches in diameter, and bind a strip of fine flannel round the edges. Breathe on this and press it gently on a piece of the leaf, which by this may be taken from the leather and carried to any part of the sizing where it will best fit, and to which it will readily adhere. Thus the sizing may be readily covered with the leaf, very little of which will be wasted. Afterward the whole may be brushed over lightly with cotton or a soft brush, and the superfluous gold or silver will be brushed off, leaving the letters or figures entire. When the work has thus remained 2 or 3 days, it may be rubbed with a piece of silk, which will increase its metallic luster. Note: it is very essential that the varnish of the ground should be thoroughly dry, that it may not be adhesive in the least degree, otherwise the leaf will stick where it should not, and materially injure the work. When plain gilding is required for vanes, balls, etc., the leaves of gold or silver may be applied to the work directly from the book, without cutting or dividing them. 2. The art of burnish gilding. Make a sizing by boiling the skins of beaver and muskrats, which may be readily procured at a hat manufactory, in water, till it is of sufficient strength that by cooling it will become a stiff jelly. Strain the liquor while warm, and give your work 1 coat of it with a brush. When this is dry, add a little fine whiting to the sizing, and give the work 1 coat of this. Then add as much whiting as will work freely under the brush, and lay on 5 or 6 coats of this, allowing each a sufficient time to dry. Smooth the work by wetting it and rubbing it with a piece of pumice stone, which should be previously cut and fitted to the moulding or other work that is to be gilt. Afterward, when the work is dry, rub it with some fine sandpaper, then take some burnished gold size, which is composed of pipe clay, plumbago, beef tallow, and Castile soap, but may be easily procured ready-made, and dilute it with water till it is of the consistence of very soft putty, and afterward with the above-mentioned sizing till it will flow freely from a brush, and give the work 3 successive coats of this. When the last is dry, dip a camel-hair pencil in a mixture of equal quantities of rum and water, and with it wet a small part of the work, and immediately, while it is flowing, lay on a leaf of gold, brushing it down with a very soft, flat camel-hair brush, with which also the leaf is usually conveyed from the book to the sizing. Proceed thus till the whole is gilt, and let it dry. When the work is sufficiently dry to take a fair polish by burnishing, which can only be ascertained by applying the burnisher to different parts of the work occasionally while it is drying, rub over the whole carefully with a flint burnisher or with the tooth of a wolf or dog being fixed in a convenient handle till the whole acquires a brilliant polish, except such parts as are required to remain in a rough gilt state, which parts are usually flatted by a coat of thin sizing. Such are the principal rules of the art of burnish gilding, but as this business requires some variation of management according to the state of the weather and other circumstances, it may not be expected that any person should become very expert in the art without the advantage of some experience and practice. 3. Ornamental bronze gilding. This is performed by means of gold or silver reduced to an impalpable powder called bronze. One method of preparing it is to leviate any quantity of gold or silver leaves on a stone, with some clarified honey. Dilute the honey with clear water, and the bronze may settle. Pour off the water and honey, and add fresh water to the bronze, which, after being thus thoroughly washed, may be dried on paper and is ready for use. Another method of preparing the gold bronze is to precipitate the gold from its solution in nitromuriatic acid, C5, by adding sulphate of iron to the solution, then washing it as directed above, but in general it will be found much cheaper to buy the bronze ready prepared. The ground for this work must be varnished with a mixture of copal varnish and an equal quantity of old linseed oil, and whatever figures are to be formed in bronzing must be represented by holes cut through pieces of paper. Lay these patterns on the work, when the varnish is so dry as to be but slightly adhesive, but not press them down any more than is requisite to keep the paper in its place. Then take a piece of soft glove leather, moisten it a little by breathing on it, and dip it in some dry bronze, and apply it to the figures, beginning at the edges. Tap the figure gently with the leather, and the bronze will stick to the varnish according to the pattern. Thus any figure may be produced in a variety of shades, by applying the bronze more freely to some parts of the work than to others. If some internal parts of the figures require to be more distinct than others, they may be wrought by their peculiar patterns, or may be edged with dark coloured paint. In some work it may be well to extend the varnish no farther than the intended figures, in which case any projecting or branching parts of the figures may be drawn with a camel hair pencil, and the patterns may in some measure be dispensed with. In either case the work must afterwards have one or more coats of copal or shellac varnish. End of section 1.
Section 2 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 4. To enamel picture glasses with gold. The glass must first be washed perfectly clean and dried, then damp it by breathing on it or wet it with the tongue, and immediately lay on a leaf of gold and brush it down smooth. When this is dry, draw any letters or flowers on the gold with Brunswick blacking C51, and when dry, the superfluous gold may be brushed off with cotton, leaving the figures entire. Afterward, the whole may be covered with blacking or painted in any color, while the gold figures will appear to advantage on the opposite side of the glass. This work may be elegantly shaded by scratching through the gold with a small steel instrument, in the end of which many sharp points are formed. Previous to laying on the blacking, oil paints of any kind may be substituted in the place of the blacking, but will not dry so quick. 5. To wash iron or steel with gold. Mix together in a phial 1 part of nitric acid with 2 parts of muriatic acid and add as much fine gold as the acid will dissolve. For this purpose, gold leaf is the most convenient as it will be the most readily dissolved. This solution is called the nitromuriate of gold. Pour over this solution cautiously about half as much sulfuric ether, shake the mixture and then allow it to settle. The ether will take the gold from the acid and will separate itself from it also and form an upper stratum in the phial. Carefully pour off this auriferous ether into another phial and cork it close. Wash any piece of steel or iron with this ether and immediately plunge it in cold water and it will have acquired a coat of pure gold. With this also, any flowers or letters may be drawn or written even with a pen and will appear perfectly gilt. The steel or iron should afterward be heated as much as it will bear without changing color, and if the steel be previously polished, the beauty of the gilding may be much increased by burnishing with a cornelian or bloodstone. 6. To wash brass or copper with silver. To half an ounce of nitric acid in a phial, add 1 ounce of water and 1/4 of an ounce of good silver. It will soon be dissolved, and if the acid and metal are both pure, the solution, which is called nitrate of silver, will be transparent and colorless. Add to this a solution of nearly 2 drachm of muriate of soda in any quantity of water. This will precipitate the silver in a white opaque mass. Pour off the water with the acid and add to the silver an equal quantity of supertartarate of potash, thus forming a soft paste. Dip a piece of soft leather in this paste and rub it on the metal to be silvered. Continue rubbing it till it is nearly dry. Then wash it with water and polish by rubbing it hard with a piece of dry leather. Another method is to add subcarbonate of potash to the nitrate of silver. As long as ebullition ensues, then the acid is poured off and the precipitate, which is white at first but becomes green when dry, is mixed with double its quantity of muriate of soda and supertartrate of potash. With this composition being moistened, the metal is rubbed over, etc. 7. To give wood a gold, silver or copper luster. Grind about 2 ounces of white beach sand in a gill of water in which half an ounce of gum arabic has been dissolved, and brush over the work with it. When this is dry, the work may be rubbed over with a piece of gold, silver or copper and will in a measure assume their respective colors and brilliancy. This work may be polished by a flint burnisher but should not be varnished. 8. To print gold letters on morocco. First wet the morocco with the whites of eggs. When this is dry, rub the work over with a little olive oil and lay on gold leaves. Then take some common printing types and heat them to the temperature of boiling water and impress the letters on the gold. Rub the whole with a piece of flannel and the superfluous gold will come off, leaving the letters handsomely gilt. Another method is to strew powdered rosin over the morocco previous to laying on the leaf. The heat of the types melts the rosin, which occasions the gold to adhere in the impressions, while the other may be brushed off. End of section 2. Section 3 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 9. To dye silk a brilliant gold color. Take any quantity of nitromuriate of gold, C5, and evaporate by exposing it to a gentle heat in a glass tumbler or phial. The gold will form itself in crystals on the bottom and sides of the vessel. Collect these crystals and dissolve them in 10 times their weight of pure water. Then put a gill of water into a common flask and add 1 ounce of granulated zinc and 1/4 of an ounce of sulfuric acid. Hydrogen gas will be evolved and rise through the neck of the flask, which must not be stopped. Immerse a piece of white silk in the above mentioned aqueous solution of gold and expose it while wet to the current of gas as it rises from the flask. The gold will soon be revived and the silk will become beautifully and permanently gilt. Any letters or flowers may be drawn on the silk with a camel hair pencil dipped in the solution, and on being exposed to the action of the gas will be revived and shine with metallic brilliancy. Note: the silk must be kept moist with water till the gold is revived. Zinc may be prepared for the above purpose by melting it and stirring it continually with a stick or iron rod while it is cooling, or it may be pulverized with a hammer as soon as it becomes solid. 10. To dye silk a brilliant silver color. Proceed as directed in the last experiment. Only use the nitrate of silver, C6, instead of nitromuriate of gold. The process of crystallizing, redissolving, etc. is the same, but the crystals of silver differ in color, being white, whereas those produced from gold are yellow. If a jar or box be filled with hydrogen gas and the silk suspended in it, the action of the gas and consequently the revivification of the metals will be more uniform. For small figures, however, it may be as well to fix a stopper in the flask, having a small orifice through it, that the gas may be thrown with some force on the silk and will have a more certain effect. A solution of muriate of tin may be managed in a similar manner, but none of these solutions can be thus revived on paper. End of section 3.
Section 4 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. 11. To silver looking glasses. Lay on a smooth board a piece of soft deerskin leather, rather larger than the glass that is to be silvered, and on the leather, having sprinkled a little fine whiting, spread a piece of tin foil of the same size. Pour on a few drops of mercury, and brush it over the tin with a smooth brush, till every part of the tin becomes bright. Then add as much mercury as will lay on the tin, and upon this lay the glass to be silvered. On the glass lay another piece of leather, of the same size, and on that another board. Take up the boards with the glass, and pressing the boards together, turn them with the glass, the other side up. Take off the upper board, and pass the glass with the tin and leather between two rollers, similar to those of a rolling press, for copper plate printing, thus to press out the mercury from between the tin and glass. Then place the glass between the boards again as before, and place a heavy weight, which cannot be too heavy unless it breaks the glass, on the upper board, which must remain 2 or 3 days. The glass may then be taken up. The practice of some is, to lay thin paper on the mercury previous to laying on the glass. This paper, being carefully drawn out after the glass is laid on, serves to remove the superfluous mercury, that the tin may come more neatly in contact with the glass. In this case no rollers are used. Concave or other fancy glasses may be silvered by making an impression with the glass in a kind of putty made of fine sulphate of lime and water, and placing the glass in the impression again with the tin foil and mercury. When the plaster is dry, and subjecting it to pressure 2 or 3 days in that situation, The experiment of silvering glass may be performed by rubbing a drop of mercury on a small piece of tin foil and pressing it upon a piece of glass with the finger, or a piece of soft leather. In this case, the glass will have acquired the reflective property of a mirror, and if a similar pressure be continued a few hours, the tin will adhere permanently. 12. To write on paper with gold or silver. Make a sizing as strong as will flow freely from the pen, by dissolving equal quantities of gum arabic and loaf sugar in water. Write with this on paper and let it dry. Then moisten the paper by breathing on it, or by holding it over hot water, and immediately lay pieces of gold or silver leaf on the lines of the writing, pressing them down gently with a dry hair pencil. Otherwise brush gold or silver bronze lightly over the writing, but this will not have so brilliant an appearance. Allow the sizing to dry again, and then brush off the redundant gold or silver with cotton. This writing, if performed with leaf gold or silver, may be burnished with a flint burnisher or a cornelian or bloodstone. Gold letters may also be written or drawn with a hair pencil by means of gold bronze mixed with weaker gum water, to which may be added a little solution of soap which will make it run more freely. But no preparation of solution of gold has yet been discovered, which may be easily revived on paper.
Section 5 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 13. To make good shining black ink. Take 2 ounces of nut galls in coarse powder, 1 ounce of logwood in thin chips, 1 ounce of sulfate of iron, 3/4 of an ounce of gum arabic, 1/4 of an ounce of sulfate of copper, and 1/4 of an ounce of loaf sugar. Boil the galls and logwood together in 3 pints of water till the quantity is reduced to 1/2. Then the liquor must be strained through a flannel into a proper vessel and the remainder of the ingredients be added to it. The mixture is then to be frequently stirred till the whole is dissolved, after which it must be left at rest for 24 hours. The ink may then be decanted from the gross sediment and must be preserved in a glass bottle well corked. 14. Blue ink. Dissolve 1 ounce of gum arabic in a pint of water. In a part of this gum water, grind a small quantity of best Prussian blue. You may thus bring it to any depth of color you choose. Indigo will answer this purpose very well, but is not so fine a color, nor will it remain suspended so uniformly in the water. 15. Red ink. In the above mentioned gum water, grind very fine 3 parts of vermilion with 1 of lake or carmine. This is a very perfect color, but may require to be shaken up occasionally. To make the common red ink, such as is used by bookbinders for ruling, etc., infuse half a pound of rasped Brazil wood for 2 or 3 days in a pint of vinegar, then filter or strain it and add 1 ounce of gum arabic and 1 ounce of alum. It may afterward be diluted occasionally with water. 16. Yellow ink. Steep 1 ounce of turmeric in powder in half a gill of alcohol, let it rest 24 hours and then add an equal quantity of water. Throw the whole on a cloth and express the colored liquor which mix with gum water. Rum or other spirits may be substituted in the place of alcohol. A solution of gamboge in water writes a full yellow but comes far short of turmeric in brightness. 17. Green ink. To the tincture of turmeric prepared as above, add a little Prussian blue. A variety of tints may be formed by varying the proportions of these two ingredients, and no artificial color can excel it in beauty. 18. Purple ink. To the blue ink described at 14, add some finely ground lake, or instead of this, the expressed juice of the deepest colored beets may be substituted, but is more liable to fade. With either of these, a variety of tints may be formed by varying the proportions. 19. To write in various colors with the same pen, ink and paper. Take a sheet of white paper and wet some parts of it with a solution of subcarbonate of potash, which must be diluted with water so as not to appear on the paper when dry. Wet some other parts with diluted muriatic acid or with juice of lemons. Some other parts may be wet with a dilute solution of alum and others with an infusion of nut galls, water in which bruised or pulverized nut galls have been steeped. None of these preparations must be so strong as to color the paper any. When these are dry, take some finely powdered sulfate of iron and rub it lightly on some parts of the paper that have been wet with the subcarbonate of potash and infusion of galls. Then with the juice of violets or of the leaves of red cabbage, write on the paper as usual with a pen. The ink is of itself a faint purple where the paper was wet with acid. The writing will be bright red. On the subcarbonate of potash, it will take a beautiful green. On the alum, it will be brown. On the subcarbonate of potash that was rubbed with powdered sulfate of iron, it will be deep yellow. And on the infusion of galls that was rubbed with the powder, it will be black. The juice of violets will sometimes take a brilliant yellow on the alkali if it be very strong. The juice of violets or red cabbage may be kept a long time by means of the addition of a few drops of alcohol, or the leaves may be dried by the fire and thus may be kept ready for use, and it is only requisite to steep them in hot water in order to prepare the ink at any time. Note: the yellow ink described at 16 writes a full red where the paper has been wet with the solution of subcarbonate of potash, while the solution of sulfate of iron, which has no color of itself, writes a deep yellow on the alkali and black on the infusion of galls. End of section 5.
Section 6 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Abai in September 2023. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. Sympathetic inks for secret correspondence. Process 1. Dissolve muriate of ammonia in water and write. The writing will be invisible. When you would make the writing appear, heat the paper by the fire and the writing will become black. Process 2. Write with a solution of sulfate of iron. The writing will be invisible. Dip a feather in an infusion of nut galls, and with it wet the paper, and the writing will become black. Process 3. Write with a dilute infusion of galls. It will be invisible. Dip a feather in a solution of sulfate of iron and moisten the paper with it, and the writing will become black. Process 4. Write with a solution of subcarbonate of potash. Wet this writing with a solution of sulfate of iron. It will take a deep yellow color. Process 5. Write with a solution of sulfate of copper. No writing will be visible. Wash the paper with a solution of prussiate of potash. The writing will then get a reddish-brown color. Process 6. Write with a solution of supercarbonate of soda. Moisten the paper with a solution of sulfate of copper, and the writing will become green. Process 7. Write with diluted nitrate of silver and let the writing dry in the dark. It will be invisible, but expose the paper to the rays of the sun and the writing will become black. End of section 6.
Section 7 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betty B. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. 27. Luminous ink that will shine in the dark. To half an ounce of essential oil of cinnamon in a phial, add half a drachm of phosphorus. Cork the phial slightly and set it or suspend it near a fire, where the heat may be nearly equal to boiling. Continue the heat 4 or 5 hours, shaking the phial frequently, but cautiously, lest any of the oil should escape or come in contact with atmospheric air, in which case it would take fire. The cork should be set sufficiently tight to exclude atmospheric air, but not so as to prevent the escape of any vapor that might be produced by excess of heat. The phial may be afterward removed from the fire and suffered to cool. With this phosphorized oil, any letters may be written on paper, and if carried into a dark room, will appear very bright, resembling fire. The phial should be kept corked closed, except when used. 28. To make a writing appear and disappear at pleasure. Dissolve equal parts of sulfate of copper and muriate of ammonia in water, and write. When you would make the writing appear, warm the paper gently by the fire. The writing will appear in a yellow color, but as soon as you take the paper into the cold air, the writing will vanish. This may be often repeated. 29. To make a writing vanish and another appear in its place. Write on paper with a solution of subcarbonate of potass. The writing will be invisible. Mix together equal parts of solution of sulfate of iron and infusion of galls. Write with this mixture, which is black, on the same paper. Then add to the black liquor a little sulfuric acid, sufficient to deprive it of color. Wet the paper with this compound. The acid will discharge the color from the last writing, while the alkali of the first will precipitate the gallate of iron, and the writing will become black. 30. To restore old writing that is nearly defaced. Boil 1 ounce of powdered nut galls for an hour or more in a pint of white wine. Filter the liquor, and when cold, wet the paper with it, or pass it on the lines with a camel hair pencil, and the writing will be much revived. End of section 7. Section 8 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betty B. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. 31. To paint a picture that will appear and disappear occasionally. To half an ounce of nitric acid, add 1 drachm of cobalt, 1 drachm of muriate of soda, and 2 ounces of water. Set it in a sand bath or on warm ashes, where it must remain 5 or 6 hours. Then filter the solution, which is nitromuriate of cobalt, and with it draw the trees and shrubbery of a design picture. Then, with a solution of oxide of cobalt in acetic acid, draw some distant mountains, fences, etc., and with muriate of copper, the compound solution described at 28, draw some flowers, buildings, etc. These will all be invisible when dry, but warm the paper and the picture will appear in green, blue, and yellow. It will disappear again when the paper becomes cold. 32. Landscape painting on walls of rooms. Dissolve half a pound of glue in a gallon of water, and with this sizing mix whatever colors may be required for the work. Strike a line round the room nearly breast high. This is called the horizon line. Paint the walls from the top to within 6 inches of the horizon line with sky blue, composed of refined whiting and indigo, or slip blue, and at the same time paint the space from the horizon line to the blue with horizon red, whiting colored a little with orange lead and yellow ochre, and while the two colors are wet, incorporate them partially with a brush. Rising clouds may be represented by striking the horizon red color upon the blue before it is dry with a large brush. Change some sky blue about 2 shades with slip blue, and paint your design for rivers, lakes, or the ocean. Change some sky blue 1 shade with forest green, slip blue, and chrome yellow, and paint the most distant mountains and highlands. Shade them while wet with blue and heighten them with white, observing always to heighten the side that is toward the principal light of the room. The upper surface of the ocean must be painted as high as the horizon line, and the distant highlands must rise from 10 to 20 inches above it. Paint the highlands, islands, etc., of the second distance, which should appear from 4 to 6 miles distant, with mountain green, 2 parts sky blue with 1 of forest green. Heighten them, while wet, with sulphur yellow, 3 parts whiting with 1 of chrome yellow, and shade with blue black, slip blue and lamp black equal. Paint the lands of the first distance, such as should appear within a mile or two, with forest green. Heighten with chrome yellow and shade with black, occasionally incorporating red ochre, French green, or whiting. The nearest part, or foreground, however, should be painted very bold with yellow, ochre, stone brown, red and yellow ochres and lamp black equal, and black. Paint the shores and rocks of the first distance with stone brown, heighten with horizon red, shade with black. For those of the second distance, each color must be mixed with sky blue. The woodlands, hedges, and trees of the second distance are formed by striking a small flat stiff brush endwise, which operation is called bushing, and is applied to the heightening and shading all trees and shrubbery of any distance, with mountain green, deepened a little with slip blue, with which also the groundwork for trees of the first distance is painted, and with this color the water may be shaded a little under the capes and islands, thus representing the reflection of the land in the water. Trees of the first distance are heightened with sulphur yellow or French green, and shaded with blue black. Every object must be painted larger or smaller, according to the distance at which it is represented. Thus the proper height of trees in the second distance is from 1 to 2 inches, and other objects in proportion. Those in the first distance from 6 to 10 inches generally, but those in the foreground which are nearest are frequently painted as large as the walls will admit. The colors also for distant objects, houses, ships, etc., must be varied, being mixed with more or less sky blue, according to the distance of the object. By these means the view will apparently recede from the eye, and will have a very striking effect. 33. To paint in figures for carpets or borders. Take a sheet of pasteboard or strong paper, and paint thereon with a pencil any flower or figure that would be elegant for a border or carpet figure. Then with small gouges and chisels, or a sharp penknife, cut out the figure completely, that it be represented by apertures cut through the paper. Lay this pattern on the ground intended to receive the figure, whether a floor or painted cloth, and with a stiff smooth brush paint with a quick vibrative motion over the whole figure. Then take up the paper, and you will have an entire figure on the ground. Note: if a floor is to be thus painted in imitation of a carpet, the pattern must be perfectly square, and the figures so designed that when several of them come together they may completely match each other, and when different colors are used in the same figure they must be kept a little separate from each other and wrought with different brushes. 34. To paint in imitation of mahogany and maple. First, give the work 1 or 2 coats of straw colored paint, composed of white lead and yellow ochre, ground in linseed oil, to which may be added a little fine litharge, that the paint may the sooner dry. When this is dry, rub it smooth with sandpaper. Then, if mahogany is to be imitated, stain the work over with boiled linseed oil, colored a little with Venetian red and burnt terra di siena, equal quantities. This should be applied with a short, stiff brush and spread very thin that it may not run or drip off. Then, with terra di siena, ground very thick in oil, form the dark shades of the graining according to your design with a small flat brush. For this purpose a common sash brush may be made flat by having a small piece of wire or wood bound on each side near the handle. Some of the darker shades may be drawn with burnt umber and black, ground together, which may be applied with a camel hair pencil. If any part is to be made very light, the staining may be wiped off carefully with a ball of cotton. Light stripes or lines may be produced by drawing a piece of cork or soft wood over the work, thus taking off or removing the dark colors that the original ground may appear. To imitate maple, the work must be stained with yellow ochre and burnt umber, ground together in boiled oil. Instead of burnt umber, terra di siena, unburnt, is sometimes used, but as different kinds or parcels of it vary in color from yellow to brown, it may not be depended on uniformly. The bird's eyes and curls are formed by removing the staining from the ground with a piece of stiff leather, the edges of which are cut in notches so that the several points will touch the work at the same time. 35. The art of painting on glass. If the common cakes of watercolors are to be used in this work, they should be mixed with water in which a little muriate of soda has been dissolved. Other paints may be ground in shellac varnish or in linseed oil, but this will not dry so quick. The most proper colors for this work, on account of their transparency, are India ink or lamp black, burnt umber, burnt terra di siena, lake, and gamboge or chrome yellow. These must be laid on very thin that they may be the more transparent. Set up the glass on its edge against a window, or place a lamp on the opposite side that the light may shine through, and with a fine hair pencil draw the outlines of your design on the glass with black. Afterward shade and paint it with the above mentioned colors, observing to paint that part of the work first, which in other painting would be done last. The shading may be performed by laying on 2 or more coats of the color, where you want it darker. If transparency is not required, a greater variety of colors may be used, and laid on in full, heavy coats. Any writing or lettering in this work must be written from right to left, contrary to the usual order. In some pieces, the body of some of the principal objects may be left blank, so that by placing pieces of silk or paper of different colors on the opposite side of the glass, the picture will also appear in different colors, and may be changed from one color to another at pleasure. End of section 8.
Section 9 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 36. Best method of polishing steel. For this purpose, a wheel must be provided that is perfectly round and the rim of it covered with deer skin or buff leather. The diameter of the wheel for common purposes may be about 2 feet, but for polishing razors and some other similar instruments, the wheel should not be more than 5 or 6 inches in diameter and 2 inches thick. The steel must first be ground smooth as possible on a common or fine-grained stone. It may then be applied to the polishing wheel, which must be turned with such velocity that the surface or rim may move at the rate of from 40 to 60 feet in a second, and the leather must frequently have a powder applied called crocus of iron which is prepared by calcining sulfate of iron in a crucible till it becomes a fine red oxide resembling rust. For ordinary work, the leather may be moistened with olive oil that it may be better retain the powder, but it will give a more perfect polish if kept dry. If any perfectly plain surfaces, such as mirrors, are to be polished, they must be applied to the sides of a wheel and not to the edge or rim in the manner of other work. 37. To make letters or flowers of blue on polished steel. Hold the steel over a charcoal fire till it becomes blue. Let it cool. Then with equal parts of rosin and beeswax melted together, colored a little with lamp black and diluted with spirits of turpentine, so as to work freely with a camel hair pencil, draw any letters or figures on the steel while it is a little warm. When the steel has become cold, wash it over with muriatic acid diluted with 2 parts water to 1 of acid, thus take off the blue color and then wash it with clear water. Afterward the varnish, being warmed a little, may be readily washed off with spirits of turpentine and the letters or flowers will remain blue. Note: if letters are formed of polished steel with this varnish and the body of the metal be also covered with it, except a small space round the letters, and then bathed with muriatic acid, the space round the letters will become a dull iron color, while the letters and the body of the steel will retain their polished surface and brilliancy. 38. To preserve the brightness of polished steel. Grind an ounce of native plumbago, such as is used for making lead pencils, very fine in a gill of spirits of turpentine, then add an ounce of clean beeswax, apply a gentle heat till the wax is melted, and continue stirring it till it is nearly cold. Brush over the steel with this composition, and when the spirits have evaporated, rub the work hard with a piece of glove leather and wipe off nearly all the wax, that the metal may retain its brightness. This may be applied to iron or steel in machinery or other work and will be found to answer a much better purpose than oil, as it is less liable to collect dust from the atmosphere and is in general much more durable. 39. To give steel a temper to cut marble. No temper can be given to steel in which hardness is combined with tenacity more than in that given to files at the file manufactories, which is accomplished by the following process. To boiling water, add about twice as much finely ground muriate of soda as the water will dissolve and as much rye flour as will, with the other, make a thick paste. Lay a coat of this paste over the steel, which must be ground or filed previous to tempering, and subject it to a full red heat in a fire of charcoal, mixed with about a third part of animal coal, coal of bones, horns, leather, etc., and then suddenly plunge it 3 or 4 feet deep in exceeding cold water. By thus immersing the steel rather deep in the water, there is a double advantage. For the water which becomes heated by contact with the steel will rise and its place be supplied continually by fresh cold water, and at the same time the pressure of the water on the coating of paste will make it adhere more closely to the steel while it is cooling. The paste may then be shell off and the steel will be found as bright as before, or at least will not have been essentially oxidized by the operation. End of section 9. Section 10 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by unknown. 40. To wash iron or steel with copper. Dissolve sulfate of copper in water in the proportion of 1 to 3. Wash the iron or steel with it, and it will instantly be covered with reduced copper. This is best performed by applying the solution with a brush, which must be followed directly with a sponge of clear water. In this manner, any letters or figures may be drawn with a camel hair pencil or a pen, and if it be on polished steel, the letters or flowers will assume the brilliancy of the steel and appear like highly polished copper. It may sometimes be requisite to cleanse the metal by washing it with diluted muriatic acid, that the copper may adhere the more readily. If the steel thus ornamented be held over a charcoal fire, the copper figures become blue first, and when the steel becomes blue, the copper takes a gold color, but is restored again to its original color by diluted muriatic acid. 41. To give iron the whiteness of silver. To nitric acid diluted with an equal quantity of water, add as much mercury as the acid will dissolve, then add to the solution 3 or 4 times as much water, and having given the iron a coat of copper as directed in the last experiment, brush it over in the same manner with the diluted nitrate of mercury. Its appearance will be equal, if not superior, to that of real silver. In this manner, any common or rough iron work may be apparently silvered at a most insignificant expense. 42. To wash iron with tin. Small pieces of iron may be tinned after being filed bright by washing them with a saturated solution of muriate of ammonia in water and dipping them while moist in a vessel of melted tin. If the iron is of such form as cannot be conveniently filed, it may be immersed in nitric acid, diluted with as much water as acid. When the acid begins to act sensibly on every part, it may be washed with water, and then with the muriate of ammonia, and if a little fine rosin be sprinkled on it previous to dipping it in the tin, it may be an advantage. The iron must remain in the tin till it becomes nearly as hot as the tin, otherwise it will be coated too thick. Muriatic acid may sometimes be used instead of muriate of ammonia, and if the iron is not filed, it will answer a better purpose. The inside of cast iron vessels may be tinned as follows. Cleanse the iron by scouring or rubbing it with a sharp grained stone, keeping the iron wet with diluted nitric acid. As the most prominent parts of the iron will be first brightened by the stone, the acid will also commence its action on the same parts, which will very much facilitate the work, while the hollows and deeper parts of the surface will remain untouched till the iron is nearly smooth. When this is accomplished, wash the iron with water and then with clear muriatic acid, turn the vessel over to drain off the superfluous acid, then set it upright and fill it with melted tin, which must be poured in cautiously directly on the bottom of the vessel first, and the steam of tin increase till the vessel is full. Then pour out the tin suddenly and invert the vessel till it is cold. Sheets of iron are tinned in the manufactories of tin plate by immersing the sheets endwise in a pot of melted tin, the top of which is covered with about 2 inches depth of tallow. This tallow answers a better purpose after it has become brown by use than it does at first. The only preparation of the iron sheets is to score them perfectly clean and bright. End of section 10. Section 11 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by unknown. 43. To give tin the whiteness and brilliancy of silver. To an ounce of nitric acid diluted with an equal quantity of water, add nearly an ounce of mercury or as much as the acid will dissolve. When this is dissolved, add to the solution gradually half an ounce of sulfuric acid. This will precipitate the mercury in the form of a white powder. When this has subsided, pour off the acid and add clear water. Thus, wash the powder from the acid, then pour off the water, and while the precipitate is moist, or if it be suffered to dry, it may be again moistened with water. Rub it over the tin with a piece of glove leather. Then wash the tin with water, and when it is dry, rub it pretty hard with a piece of fine woolen cloth. It will resemble polished silver. 44. To give tin a changeable crystalline appearance. Cleanse the tin by washing it with warm soap and water and rinse it in clear water. Then heat the tin to the temperature of bare sufferance to the hand and pour on it or apply with a brush or sponge a mixture of 1 ounce of muriatic acid with 1/4 of an ounce of sulfuric acid and 2 ounces of water. Then immediately wash the tin in clear water. Another method is to apply in the same manner a solution of 2 ounces of muriate of soda in 4 ounces of water with 1 ounce of nitric acid. In either case, if the crystalline figures are not bold enough, the operation may be repeated. If a very small figure is required, the tin may be heated nearly to flowing and plunged into cold water, slightly acidulated with nitric and muriatic acids. If a little solder is drawn over the tin with a hot iron or copper in such manner as to form a cross or circle and the opposite side of the tin be afterwards crystallized, it will have a beautiful effect. 45. To make a gold colored varnish for tin. To half a pint of alcohol in a flask, add 1 ounce of gum shellac and half an ounce of turmeric, both in powder. Set the flask in warm place, frequently shaking it for 12 hours or more, then filter or strain off the liquor, which may be occasionally diluted with new rum. If a color is required resembling Dutch gold, a small quantity of dragon's blood may be added or substituted in the place of turmeric. When this varnish is used, it must be applied to the work freely and flowing and must not be brushed or rubbed while it is drying. One or more coats of this varnish or lacquer, as it is sometimes called, may be laid on the work as the color is required to be deeper or lighter. Note: to make a rose-colored varnish, proceed as above directed. Only substitute 1/4 of an ounce of the best lake, finely ground, in the place of turmeric. A transparent blue varnish may also be made by means of Prussian blue and purple or green by adding a little blue to the gold or rose-colored varnishes. These lacquers are frequently employed for washing silver bronzed ornaments to give them the appearance of gold or copper. End of section 11. Section 12 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by unknown. 46. To make shellac varnish for Japanning, to 1 quart of the best alcohol, add half a pound of the thinnest and most transparent gum shellac. Mix and shake these together and let them stand in a warm place for 2 or 3 days. Then strain the varnish through a fine flannel and bottle it. Shellac varnish is used for Japanning lamps, tea trays, etc. Any of the colors commonly used for oil painting may be ground in this varnish and should be applied to the work with a smooth brush and in a warm place, and the work to be japanned should be perfectly dry and warm. Note: most of the writers on the subject of japanning have recommended seed lac varnish, but it is a fact, though not so generally known as it ought to be, that shellac and seed lac are the same substance. The only difference is that shellac is in a more clarified and refined state than that which is called seed lac. 47. To make the best copal varnish. Take 1 pound of gum copal and melt in a flask over a brisk fire of charcoal. At the same time, in another flask, boil or heat to the point of boiling 1 pint of linseed oil. As soon as the gum is melted, take it from the fire and add the hot oil in small quantities, at the same time stirring or shaking it till they are thoroughly incorporated. Allow the mixture to cool below the boiling point of water and then add nearly a quart of spirits of turpentine. Cork the flask slightly and expose it for a few days to the rays of the sun, which will make it work more smooth and shining. If a larger quantity is to be made, a copper boiler that is small at the top will answer to melt the gum in. For ordinary or coarse work, a larger proportion of oil and a little rosin may be added. If oil is used in which red lead and litharge in the proportion of half a pound of each to a gallon of oil have been previously boiled, the varnish will the sooner dry. 48. To make a spirit varnish for pictures and fancy boxes. To a pint of alcohol in a flask, add 4 ounces of gum mastic and 1 ounce of gum sandarac, both in powder. Expose the mixture to a gentle heat, sufficient to produce a slight ebullition for a few minutes, frequently shaking it, and the gums will be dissolved. Strain the varnish through a fine flannel, bottle and cork it. Some recommend the addition of vinous turpentine, by means of which a small quantity of gum copal, finely powdered, may also be dissolved. But as vinous turpentine contains a portion of spirits of turpentine, it renders the varnish too penetrating for many purposes, and even the gum sandarac may be omitted without any essential disadvantage. This varnish should be a little warm when used. 49. To make elastic varnish for umbrellas or hat cases. To a pint of spirits of turpentine in a flask, add 1 ounce of gum elastic, cut into very small pieces, put in the cork slightly, and set the flask in a warm place, where the heat may not be equal to that of boiling water, till the gum elastic is dissolved, which may be effected in 4 or 5 hours. Then strain the solution through a strong linen or cotton cloth and add half a pint of boiled linseed oil. Note: a larger proportion of gum elastic may be dissolved and a less quantity of oil added, by which means the varnish will be more elastic but will not have so smooth and permanent a gloss. 50. To varnish maps and pictures. Take a piece of linen or cotton cambric, rather larger than the map or picture to be varnished, and draw it straight upon a frame of convenient size and confine it at the edges by small tacks or nails. Lay a thin coat of fine rye flour paste on this, and on the back of the paper that is to be varnished, lay the paper on the cambric and press them together till the paper adheres firmly in every part. When this is dry, give the face of the print 2 or 3 coats of a strong solution of gum arabic in water, allowing each sufficient time to become perfectly dry. This sizing must be applied with a large smooth brush and must be sprayed over the work very quickly and with as little brushing as possible. Afterwards, give the work one or more coats of the varnish described at 48. Note: very small prints may not require to be pasted on cambric, and if the paper be very thick, the varnish may be applied without the previous sizing. Isinglass, which may be readily dissolved in boiling water, is sometimes added to the gum arabic and increases the strength of the sizing, but is somewhat less transparent than pure gum arabic. A more simple method of varnishing prints is to size them with a solution of loaf sugar and finish with a solution of rosin in spirits of turpentine. End of section 12. Section 13 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 51. To make Brunswick blacking for picture glasses. Take 1 pound of gum asphaltum and melt it over a slow fire. Then take it from the fire and add spirits of turpentine in small quantities, stirring it briskly till it is of the consistence of varnish. As there is some danger of its taking fire when the spirits of turpentine is added, it may be well to be provided with a piece of wet flannel to throw over it if that should happen. When it is nearly cold, strain it through a flannel and bottle it for use. This blacking is used for bordering picture glasses and is probably the most perfect black in nature. It is waterproof and dries very quick. 52. To make a print appear on a gold ground. Dilute Venice turpentine with spirits of turpentine till it works freely with a camel hair pencil. Lay a coat of this varnish on any part of a print or picture, observing to keep the pencil within the lines that the varnish may not spread beyond. Then lay a coat of the varnish on the same part of the back of the paper and lay on a leaf of gold over the varnished part. Press down the gold very gently with cotton, and the varnish having rendered the paper transparent, the face of the picture will appear as if those parts were printed in gold. By this varnish, which is less liable to spread in the paper than oil, pictures may be so prepared that the colors of various parts of them may be varied and changed at pleasure by placing pieces of silk or paper of different colors on the back of them. 53. Best method of tracing or copying a picture. Perhaps the most simple method of copying the outlines of a picture is to place the picture against a window with the paper over it on which the copy is to be drawn. The principal lines of the picture will be seen through the other paper and may readily be traced with a lead pencil. But the usual manner of copying in landscape painting, and which will answer for pictures of any size, is to rub over the back of the picture with plumbago or red ochre, then lay the picture on the ground that is to receive the copy and trace the lines with a smooth pointed steel or piece of hard wood. The ground will thus be very accurately and distinctly marked by the plumbago or ochre adhering to the ground in the lines that are traced. When several copies are to be taken from the same pattern, which frequently occurs in ornamental painting, the outlines of the first copy may be perforated with some pointed instrument, so that, being laid on the other grounds that are to receive the copies, and brushed over with a little fine dry whiting or red ochre as the case may require. The whiting or ochre will penetrate the perforated lines of the pattern and thus mark the ground on which it is laid. 54. The construction and use of a copying machine. Take two strips of wood, which may be about 3 feet long, 1 inch wide, and 1/4 of an inch thick. Lay them on a table parallel to each other and 18 inches apart. Across these, lay 3 other strips, which must be 18 inches long, that each end of each piece may rest on one of the longer strips. 2 of these must lie across the opposite ends of the longer pieces and the other across the center, thus forming 2 squares. Drive a pin through the ends of the short pieces or confine them by rivets to the others, but not so as to prevent their playing circularly on the rivets. Then drive a pin or pivot through the center of the middle crossbar into the table or board on which the work lies. In one end of one of the long strips, which may project a little over the crossbar, fix a lead pencil with the point downward so that it may bear lightly on the board, and under this pencil place the paper that is to receive the copy, and in the opposite end of the other piece fix a smooth iron point in a manner similar to that of the pencil, and under this point place the picture that is to be copied. Then with the iron point carefully trace the lines of the picture, and the pencil in the opposite corner will move in a transverse direction and draw the same picture very accurately on the other paper. If you fix the pencil halfway between its former place and the middle crossbar and remove the pivot to a point that is directly in a line with the pencil and the iron point, it will give a copy in exact proportion, but only 1/4 part as large as the picture that is copied. Thus the copy may be decreased or increased to any size and still retain its regular proportions. In this manner, painting on wood or canvas may be copied, which could not readily be done in any other way. 55. To produce the exact likeness of any object instantly on paper. This may be readily effected by laying the paper on a table and holding a double convex lens, a common sunglass, over it, and then placing a mirror over the lens in an oblique position so as to face partly downward and partly towards the object that is to be represented. The rays of light passing from the object to the mirror will be reflected downward through the lens and produce the likeness of the object in full colors on the paper. This experiment may be easily made in the evening by reflecting the flame of a candle in this manner, which will appear very brilliant on the paper. But in order to render the reflection of an object distinctly visible by daylight, it may be requisite to exclude nearly all the light from the paper except what falls through the lens. In all cases, the lens must be placed at a distance above the paper according to its focus or the distance at which it would contract the rays of the sun to the smallest point. A very convenient camera obscura for drawing landscapes or even portraits may be constructed as follows. Make a box of boards in the form of a regular cube, being 1 foot in length, breadth, and height. Bore a hole of 1 inch diameter through the center of the top, and on this fix a double convex lens, the focus of which must reach the bottom of the box. Make an aperture of about 6 inches in length and 1 in breadth through one side of the box at the top by shaving off or hollowing the edge in such manner that when you put your face to the aperture to look into the box, it will exclude all the light except what falls through the lens. Make a hole through each end of the box near the bottom large enough to put in the hands with paper and pencil. On the top of the box, on the right and left sides of the lens, fix two pieces of boards which may be about 4 inches high, 8 inches long, and 3 inches distant from each other. Between these boards, fix a piece of looking glass 3 inches square and facing from you, the lower edge of the glass being near the lens on the side towards you, and the upper edge inclining towards you about 30 degrees from the perpendicular. Directly over and nearly 4 inches above the lens, place another mirror, the center of which must face directly towards the lower edge of the first. Cover the glass box so as to exclude all the light from the glasses except what falls on them horizontally from objects directly in front of you, and place a sheet of paper on the bottom of the box inside. The rays of light passing from objects in front will be reflected from the first mirror to the second, and from the second through the lens to the paper, where you will have a perfect similitude of the objects in view in full colors and true perspective, and may trace them on the paper with a pencil or pen. End of section 13. Section 16 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Prajakta. A select collection of valuable and curious arts and interesting experiments by Unknown. 56. Copper plate engraving. For this purpose, provide a plate of copper rather larger than the design that is to be engraved and maybe about 1/16 of an inch thick. Plenish by rubbing it first directly lengthwise and afterwards breadthwise with a piece of pumice stone, which may be dipped occasionally in a mixture of 1 part nitric acid with 6 or 7 parts water. Then wash the copper with clear water and rub it with an oil stone that has a plain surface, and then polish it with a piece of charcoal that has been ignited to redness and quenched in cold water. Afterwards, burnish the copper by rubbing it with polished steel. Lay a piece of transparent paper on the design that is to be engraved and trace the principal lines with a lead pencil. Then brush over the copy or tracing with dry red ochre, and having rubbed the copper plate with a piece of beeswax, lay the red side of the tracing on the plate. Then with a smooth iron point, trace the same lines again, that they may thus be transferred to the plate by means of the red ochre and wax. Take up the paper and trace the lines on the plate with a needle, thus scoring the lines slightly on the copper. Then warm the plate and wipe off the wax or wash it off with spirits of turpentine and rub the plate with fine dry whiting. The next instrument to proceed with is the graver, consisting of a blade of steel about 3 inches long, which is fixed in a convenient handle like an awl. The form of the graver should be triangular or between a triangle and lozenge, leaving two sides plain and the other round or svelte, and should taper regularly from the handle to the point or nearly so, but the point must be ground off obliquely so that the edge may extend a little farther than the back, and the edge should rise a little rounding towards the point. It is very essential that the edge and point of the graver should be kept very sharp. The manner of holding the graver is to take the handle into the hollow of the hand, pressing it with 3 fingers on one side and the thumb on the other, and extend the forefinger on the back of the blade towards the point. The edge of the graver must rest on the plate, and its motion when cutting must be endwise in all cases, though there evidently might be a graver constructed which might in some cases be handled in a manner more similar to that of a pen or pencil. A graver of a square form may also be requisite for cutting large and broad lines occasionally. In proceeding to engrave the plate, begin with the outlines, observing to press harder or lighter on the graver as the lines require to be larger or smaller and finish each line with the same motion if possible without taking the graver off the plate. Having cut the outlines, proceed to fill up and shade the work discretionally according to the design. It may be requisite, after part of the work is engraved, to scrape it lightly with the edge of the graver to take off any roughness that may have been formed on the part engraved. If after finishing the design, any part appears to have been improperly executed, such parts may be erased by the burnisher and may be re-engraved with the requisite amendments. 57. Etching on copper plates. Melt together 2 ounces of beeswax and 1 ounce of anise turpentine, and when the wax is melted and boils, add by small quantities 2 ounces of gum asphaltum, stirring the mixture briskly at the same time, and when the mixture is well incorporated, take it from the fire. Let it cool a little and then pour it into warm water, and by working it with the hands, form it into balls of about an inch in diameter and wrap each of them in a piece of taffety or thin silk. Then, having prepared and polished a plate of copper as directed for copper plate engraving, warm the plate sufficiently to melt the balls of wax varnish and rub one of them over it till every part of the polished side is covered with the varnish. Then with a ball of cotton wrapped or tied up in taffety, beat every part of the varnished plate gently while the varnish is yet flowing, that it may spread the more even and uniformly. Then hold the plate in a horizontal position with the varnished side down and hold the flame of a wax candle under it or a small roll of paper that has been dipped in melted wax, and thus blacken the varnish while the plate is yet warm enough to keep it in a melted state. When the varnish has become sufficiently and uniformly black, let the plate cool, and having drawn the design on transparent paper, rub over the face of it with chalk, then wipe off most of the chalk with a piece of flannel, lay the chalked side on the varnish, and trace the lines somewhat minutely with a smooth round pointed needle. Then take up the paper and proceed to scoring the lines in the varnish. For this purpose, you must be provided with several needles of different sizes and fixed in handles which may be about 4 inches long and nearly half an inch in diameter, and the needle may project 3/4 of an inch from the handle. Some of these may be ground a little flat on one side and others may be round but taper more abruptly at the point. These needles may be held and managed much the same as a pin. Begin scoring with the outlines, observing to cut completely through the varnish, but it is not requisite to scratch the copper except in making very heavy lines, when it cannot well be avoided. Having finished scoring the varnish according to the design, fix a border of wax composed of 2 parts beeswax and 1 of anise turpentine round the work on the margin of the plate. This border may be about half an inch high and must be fixed to the plate while warm. Then pour on as much nitric acid diluted with an equal quantity of water as the plate with the border will contain. In about 15 minutes, pour off the acid and examine whether it has sufficiently corroded any part of the work. If so, lay a mixture of warm tallow and linseed oil over such parts with a hair pencil and again pour on the acid. In half an hour, more the acid may be poured off, and the plate being warm, the border may be removed and the varnish may be wiped off with a piece of linen cloth. The plate may then be washed with olive oil and cleansed as before with dry fine whiting. Note: different artists use a variety of different preparations of varnish for the purpose of etching. In some old recipes, virgin wax, calcined asphaltum, gum mastic, amber, colophony, Greek pitch, burgundy pitch, black pitch, resin, shoemaker's wax, etc., etc., are mentioned. But it is believed that the above described varnish, while it is much more simple, will answer equally as well for young practitioners. And it is not expected that any will attempt very nice work without further information than they could expect to obtain from the sketches in this little collection. 58. Engraving and scraping in mezzotinto. Having prepared a plate of copper, proceed to score it so full of lines, cross lines and diagonal lines, that when they are filled with ink, the plate may appear quite black. For this purpose, an instrument will be requisite that is fashioned similar to a chisel, the round or sloping side being scored or filed near the point, with lines or notches very near to each other, so as to form a set of sharp uniform teeth at the edge. This instrument is called a cradle and should be a little round at the corners. This cradle must be moved over the plate in the manner of a graver, scoring the plate uniformly in various directions. When the scoring is finished, take a scraper, which may be similar to a knife, having two edges and sloping on each side towards the point. With this, scrape off the roughness of the plate in such places as is required to be the lightest in the print. Such parts as require to be shaded partially may not be scraped so deep, while the points that are to be the brightest may be burnished quite smooth with the polished end of a piece of steel, about the size of a large nail, and some of the heaviest outlines may be cut with a graver. Thus any portraits or other figures may be formed on the plate with due proportion of light and shade, and will, if properly managed, give an impression on paper equal in elegance to any that might be produced by other means. 59. Etching in aqua tinta. Polish the plate of copper, the same as for engraving. Moisten the plate with water and sift on finely powdered rosin and gum asphaltum so as to nearly cover the plate. Then warm the plate sufficient to make the powder adhere, but not to melt it entirely. Transfer the design to the plate and cover such parts as are intended to remain white with a varnish composed of beeswax and linseed oil, which may be colored a very little with black and must be applied to the work while warm with a camel hair pencil. Then fix a border of wax round the plate and pour on diluted nitric acid. In about 1 minute, pour off the acid and wash the plate with clear water, but without affecting the varnish. Dry the plate and apply the varnish to such parts of the design as are intended to have but a faint shade. Then apply the acid for a minute or two longer. Thus proceed biting in and stopping out alternately till every part of the design has acquired its proper shade. But if any part requires a darker shade than the ground, the powdered rosin may be removed from such parts with a scraper. When the plate has become sufficiently corroded, the varnish may be washed off with oil or spirits of turpentine, and the plate may be cleansed with white ink. 60. Copper plate printing. The paper on which impressions from a copper plate are to be taken should be moistened or weighed down 2 or 3 days previous to printing. This is performed by dipping the sheets in water severally and then laying them all together under a heavy weight till they are used. When the paper is ready, the copper plate may be warmed over a chafing dish of coals and the engraved side completely covered and all the lines filled with common printing ink or ink made of Frankfurt black finely ground in old linseed oil. This may be done by means of a printing ball, or the ink may be sprayed on the plate with a smooth stiff brush. The plate may then be wiped with a piece of linen or cotton cloth and afterward with the hand being passed slowly but hardly over the plate to take off all the ink except what remains in the lines of the engraving. To accomplish which more effectually, the hand may be rubbed occasionally with dry whiting. When the plate is thoroughly cleaned of the redundant ink, it may be laid on the table of a rolling press, and having a sheet of the moistened paper laid upon the face of it, and a piece of fine broadcloth over the paper. The whole may be passed through the press. Then, on taking up the paper, it will be found to have received a black impression from the plate according to the engraving or etching, and the plate may be again carried to the fire to be blacked again as before. This is the usual manner of printing, but when a rolling press is not at hand, the plate and moistened paper may by other means be pressed hard and firmly together, and the paper will have received the impression equally as fair. Any of the colors commonly used in oil painting, being ground very thick in oil, may be substituted for ink in copper plate printing. The plate, after being used, should be wiped clean with a piece of flannel moistened with olive oil. End of section 14.
Section 15 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betty B. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. 61. Etching letters and flowers on glass. Select a piece of glass that is thick and straight and lay a coat of melted beeswax on the fairest side. Then with a needle, penknife, or any other convenient pointed instrument, trace any design or picture which being placed under the glass may be seen through the wax, or form any letters or figures on the glass, carefully cutting or scoring quite through the wax, and making the lines large or small as occasion may require. Then warm a piece of the wax so as to form it into a roll, about 1/4 of an inch in diameter. Lay this roll round the work upon the glass, and press it down so as to make it adhere to the glass, thus forming a border. Then take some finely powdered fluate of lime, and strew it evenly over the glass, on the waxed side, that it may fill all the lines in the wax, and then gently pour upon it, so as not to displace the powder, as much sulphuric acid, diluted with thrice its weight of water, as is sufficient to cover the powdered fluate of lime. Let everything remain in this state for 3 hours, then pour off the mixture, and clean the glass by washing it with spirits of turpentine. The figures which were scored in the wax will be found engraven on the glass, while the parts which the wax covered will be uncorroded. This glass plate may be charged with ink, or any thick oil paint, and impressions may be taken from it on paper, the same as from copper plates. Only caution is requisite that the glass be not broken by the pressure. Note: the fluoric acid, which is partly absorbed by the water in the above process, being very corrosive, should not be suffered to touch the hands nor any valuable vessel whatever. 62. To print figures with a smooth stone. Take a piece of marble or slate and form a smooth plain surface on one side, and on this paint any letters or figures with common oil paint of any color. When this is dry, wet the stone with water, which will not adhere to the painted figures, especially if the paints were mixed with old linseed oil, that will produce a sharp gloss. Then apply a printer's ink ball to the plain surface, by which means the dry painted figures will be covered with the ink, while the bare surface of the stone, being wet, will not be blackened or affected by it. Press the figured surface upon some moistened paper, and it will give a fair impression of the painted figures on the paper. The block of stone must be then dipped in the water and again inked as before. Thus many impressions may be taken with a tolerable degree of accuracy. 63. To cut glass with a piece of iron. Draw with a pencil on paper any pattern to which you would have the glass conform. Place the pattern under the glass holding both together in the left hand, for the glass must not rest on any plane surface. Then take a common spike or some similar piece of iron. Heat the point of it to redness and apply it to the edge of the glass. Draw the iron slowly forward and the edge of the glass will immediately crack. Continue moving the iron slowly over the glass, tracing the pattern, and the chink in the glass will follow at the distance of about half an inch, in every direction, according to the motion of the iron. It may sometimes be found requisite, however, especially in forming corners, to apply a wet finger to the opposite side of the glass. Tumblers and other glasses may be cut or divided very fancifully by similar means. The iron must be reheated as often as the crevice in the glass ceases to follow. End of section 15.
Section 16 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Agnes Robert Bear. A select collection of valuable and curious arts and interesting experiments by Unknown. 64. Best cement for joining glass. If the glass is not likely to be exposed to moisture, the pieces may be joined by a solution of equal parts of gum arabic and loaf sugar and water, or if these are not at hand, the white of an egg may answer nearly as well. But a strong waterproof cement that is equally transparent may be made by digesting finely powdered gum copal and thrice its weight of sulfuric ether till it is dissolved. This solution may be applied to the edges of the broken glass with a camel hair pencil, and the pieces must be put together immediately and pressed close till they adhere. 65. Best cement for joining china or crockery. Heat a piece of chalk to a full red heat in a fire, and while this is heating, take the white of an egg, and mix and beat together with it 1/4 of its weight of pondered or scraped cheese. Such as is most void of cream, or oily matter is preferable, or the curd that is formed by adding vinegar to skimmed milk. Take the chalk from the fire, and before it is cold, reduce it to powder, and add as much of it to the mixture as will form a thick paste. And beat the manure all together, and use the composition immediately. When this is dry, it will resist, in a great measure, either heat or moisture. A semi-transparent cement, suitable for chinaware, may be made by gently boiling the flour of rice with water. 66. To make a strong waterproof glue. Dissolve common glue in water in the usual way, and dip into it some clean paper, sufficient to take up an ounce or more of glue. When the paper is nearly dry, roll it up, or cut it into strips, and put them into a wide-mouthed phial or flask, with about 4 ounces of alcohol. Suspend this over a fire so as to boil it gently for an hour, having the cork set in slightly to prevent its taking fire, but not so as to prevent the vapor entirely. Then take out the paper, the only use of which is to give the glue more surface for the action of the alcohol, and add 1 ounce of gum shellac in powder. Continue the heat, often shaking the mixture till the shellac is dissolved, then evaporate it to the proper consistence for use. Note: many experiments have been made in order to discover some aqueous size that, when dry, would resist moisture, and some have recommended skimmed milk, and others vinegar, as a menstruum for the glue. But it does not appear from trial that either of these are but very little better for this purpose than water, nor is it probable that any similar composition of size will resist moisture much better than common glue, especially if it be mixed with sulphate of lime, or some similar substance by way of support. End of section 16.
Section 17 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Romeo J. a select collection of valuable and curious arts and interesting experiments by unknown. 67. The art of molding figures in relief. Mix together and temper with a solution of gum arabic in water 1 part of clean sifted wood ashes and 2 parts of fine sulfate of lime. Knead this composition on a board till it has the consistence of putty. Press a ball of this putty on any metal, coin, or carved work in relief, which must be previously oiled, and let it dry. Then take off the mold thus formed and oil the part that has received the impression of the figure with olive oil. Make a small orifice through the mold from the center, or the deepest part of the impression. Also, par off the border of the mold to within half an inch of the impressed figure. Then, lay a small piece of the putty on the board and press the mold down hard upon it, that it may not only fill the mold, but that the redundant part may be pressed out beyond the border of the mold. Raise the mold a little and blow through the orifice to detach the new molded figure from the mold. Thus, any number of figures may be readily produced, suitable for ornamenting chimney pieces or moldings, and which will be very hard when dry, and may be painted with any colored oil paints, which will also preserve them from moisture. 68. To cast images in plaster. For this purpose, a model of the figure that is to be cast must be provided, and suspended by a rod or staff 1 inch in diameter and fixed in the top of the head. This model may be made of wood, chalk, or any other substance that is smooth and sufficiently cohesive to support itself. This being prepared, mix fine sulfate of lime with water to the consistence of soft putty, and having brushed some olive oil over the model, cover it completely with the plaster, which must be applied and spread over it with the hand to the depth of 2 inches or more. When the plaster is nearly dry, divide it into several parts with a thin blade, so as to take it off from the model without breaking any part. When the several parts of the mold are dry, oil them inside and put them together as before, and bind them with pieces of tape or twine. Set the mold upright and fill it with a fresh mixture of sulfate of lime and water of as much consistence as may be poured in through the aperture at the head. This plaster should be poured into the mold as quick as possible after being mixed, otherwise it would become too stiff and may be spoiled. The plaster in the mold will soon cohere, so that the mold may be taken off and the figures may be set up to dry, and the mold being oiled and put together again is ready for another cast. End of section 17. Section 18 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Romeo J. A select collection of valuable and curious arts and interesting experiments by unknown. 69. To produce embossed letters or figures on marble. Take some of the colored varnish described at 37, and with a hair pencil draw the letters, etc. on the marble, which should be previously well polished, and also cover with the varnish every part of the face of the marble that is to remain plain. Lay the marble in a horizontal position and make a border of oil putty around it, and pour the muriatic acid to the depth of half an inch on the marble. When the ebullition ceases, the acid may be drained off and the work examined, and, if the letters are not sufficiently prominent, a fresh quantity of the acid may be added. When the work has been thus corroded to the depth required, the varnish may be washed off with spirits of turpentine. The acid that has been thus employed need not be lost, for a muriate of lime being thus formed may be crystallized by slight evaporation and preserved for other purposes, or by the addition of a small quantity of sulfuric acid and the sulfate of lime is precipitated, and the muriatic may be poured off and used again for the same or a similar purpose. 70. To soften stone. Marble or granite may be deprived in some measure of the property of cohesion by being heated red hot and then quenched in oil. In this case, the carbonic acid which constitutes the cohesive property of the stone is expelled by the heat, and the vacuum thus produced in its pores are in some measure filled by the oil by the pressure of the atmosphere, by which means the stone acquires a texture quite different from what it had previously. This, however, is not often applied to any valuable purpose. End of section 18.
Section 19 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Clark Essman. A select collection of valuable and curious arts and interesting experiments by Unknown. 71. To change wood, apparently, to stone. Provide a block or plank of soft wood of the dimensions required and give it 2 or 3 coats of linseed oil, allowing each to dry. Then, having prepared some pieces of marble or granite as directed in the last experiment, pulverize them to a gross powder. Brush over the wood with a heavy coat of copal varnish, C47, mixed with an equal quantity of Venice turpentine. Let this rest about an hour, and then strew the stone powder over every part of it, so as to cover the surface completely. If marble is to be imitated, the powder of different colors, especially the white and blue, may be prepared separately, and may be strewed on the work in such shades as will appear the most natural. Granite may also be crossed or striped occasionally with streaks of a coarser grain, which will give it a very deceptive effect. When the varnish is thus covered with stone, a heavy roller or round log of wood, having a blanket folded and wrapped round it, should be rolled over the work that the larger grains, which of course will be the most exposed, may the more firmly adhere. In this manner a very perfect imitation of stone may be given, and the wood thus prepared will be exceedingly durable, and will answer, for many purposes, as well as real stone. 72. To render wood, cloth, or paper fireproof. Dissolve 1 ounce of alum, half an ounce of subborate of soda, and half an ounce of cherry tree gum in half a pint of vinegar. Dip any cloth or pieces of paper or wood in this mixture and let them dry. They cannot afterwards be ignited so as to blaze, but may be considered safe with regard to their taking fire by accident. Note: though this composition is a very powerful preventive against fire, it is too complex for common use, and has too much color for white cloths or papers. But a solution of 1 ounce of subborate of soda in a pint of water is very transparent and harmless, and will answer in most cases nearly as well. End of section 19.
Section 20 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Agnes Robert Baer. A select collection of valuable and curious arts and interesting experiments by Unknown. Section 20. 73. To produce fire readily. Process 1. Mix together gently but intimately 2 or 3 grains of chlorate of potass and an equal quantity of loaf sugar, both previously reduced to fine powder. Dip the end of a strip of glass or a straw in sulphuric acid, and with it gently touch the powder. It will instantly burst into flame. 74. Process 2. Upon 1 dram of spirits of turpentine, in a glass, pour an equal quantity of a mixture of 3 parts of nitric with 1 of sulphuric acid. Instantaneous inflammation, accompanied by the production of a large quantity of black smoke, will be the result. 75. Process 3. Take a piece of phosphorus the size of a pin's head and wrap it in a piece of dry brown paper. Rub the paper with a piece of wood, or any hard body, and it will instantly inflame. Note: in handling phosphorus, it is proper to have a piece of paper or cloth intervene between the stick of phosphorus and the fingers, and the phosphorus should be kept under water except when wanted for use. 76. To make supercombustible matches. Prepare any number of small strips or splinters of pine or other light wood, which may be about 2 inches in length and 1/12 of an inch in diameter. Dip 1 end of each in melted sulphur to the depth of 1/4 of an inch. When they are cold, scrape off most of the sulphur, and dip the ends of them slightly in a paste made of 10 parts of chlorate of potass, 5 parts of loaf sugar, and 1 part of red lead, mixed and ground together with alcohol. Afterwards they may be readily ignited or kindled at any time by application of the smallest quantity of sulphuric acid. For this purpose, the ends of them may be dipped, or rather barely touched, to the acid in a phial. Or which is a better way, a strip of glass or even wood may be dipped in the acid and applied to the match. 77. To make gunpowder. Pulverize, separately, 5 drachms of nitrate of potass, 1 of sulfur, and 1 of newly burnt charcoal. Mix them together with a little water, so as to make the compound into dough. Form this dough into rolls of the size of a small wire, which may be done by rolling small quantities between 2 boards. Lay a few of these rolls together, and cut them into very small grains, and place them on a sheet of paper, in a warm place to dry. The dough may be prevented sticking to the board while rolling it, by rubbing on the board a little of the dry compound powder. When the grains are thoroughly dry, they are ready for use or experiment. On the same principle, gunpowder is manufactured on the large scale, but then the several parts of the operation are performed by machinery, otherwise it would be a very expensive commodity. 78. To make the common fulminating powders. Grind and mix intimately 3 parts of nitrate of potass with 2 of subcarbonate of potass and 1 of sulfur. If half a drachm of this compound be placed on a shovel and held over a gentle fire, it will soon explode with loud report. It is not, however, attended with any danger. If 2 grains of chlorate of potass in powder and 1 of sulfur be mixed together and wrapped in a piece of strong paper, and the paper then be struck with a hammer, it will also explode with detonation. This experiment may require some caution. Note: the percussion powder, such as is used for priming the patent percussion rifles, is composed of chlorate of potass and flour of sulfur, with a trifling proportion of charcoal and loaf sugar being made into a paste or dough with alcohol, then grained and dried. 79. To make the mercurial fulminating powder. Dissolve half an ounce of mercury in 3 ounces of nitric acid, assisting the solution by a gentle heat. When the solution is cold, pour it upon an equal quantity of strong alcohol, previously introduced into a flask, and apply a moderate heat till the effervescence is excited. Do not forget that the mercurial solution must be poured upon the alcohol, and not the alcohol upon the solution. A white fume will soon begin to undulate on the surface of the liquor, and flow through the neck of the flask, and a white powder will be gradually precipitated. As soon as any precipitate ceases to fall, quickly pour the contents of the flask on a filter, wash the powder with pure water, and cautiously dry it by a heat not exceeding that of boiling water. The immediate washing of the powder is material, because it is liable to the reaction of the nitric acid, and while any of that acid adheres to it, it is very subject to be decomposed by the action of light. This powder, if very pure and nicely made, explodes by percussion, or a moderate degree of heat. Experiment. Place 1/4 of a grain of this powder between the ends of 2 slips of pasteboard, and paste or bind them firmly together. Hold the ends of the slips over the flame of a candle, and as soon as it becomes warm, it will explode with a loud report. This composition is less dangerous than the fulminating compounds of gold or silver, as it never explodes spontaneously, but yet it cannot be handled with too much caution. Note: the silver powder, or fulminating silver, with which torpedoes and Waterloo crackers are charged, is prepared in a similar manner, pure silver being dissolved instead of mercury, but it is too dangerous to be trifled with. End of section 20.
Section 21 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. A select collection of valuable and curious arts and interesting experiments by Unknown. 80. To kindle a fire under water. Put into a deep wine glass that is small at the bottom 3 or 4 bits of phosphorus, about the size of flax seeds, and 2 or 3 times the quantity of chlorate of potass in grains or crystals, and fill the glass nearly full of water. Then place the end of a tobacco pipe stem directly on or over the chlorate and phosphorus, and pour nearly a teaspoonful of sulphuric acid into the bowl of the pipe, that it may fall directly onto the phosphorus. A violent action will ensue, and the phosphorus will burn vividly with a very curious light under the water. 81. To light a candle by application of ice. Attach the wick of a candle, a small piece or globule of potassium, the metallic base of potass, of the size of a small shot. Apply an icicle or point of ice to the metal, and it will instantly inflame. Note: this curious substance, which has the peculiar property of being ignited by coming in contact with ice or water, has been lately discovered by Sir Humphry Davy. It is produced by making pure potass a part of the circuit of a powerful voltaic battery. It cannot be preserved but by being kept immersed in naphtha, a kind of oil of which oxygen is not a constituent. 82. To form letters or flowers of real flame. Provide a tin chest of about 18 inches in length, equal in height, and 1 inch in breadth. Chalk any design of letters or flowers on the face of this chest, and pierce each line with rows of small holes, which should be about half an inch distant from each other. Make an aperture at the top, through which pour about a pint of a mixture of rum and spirits of turpentine. Place 2 or 3 lamps under the bottom of the chest, which must be raised a little from the floor for that purpose, to warm the spirits, but not so as to cause them to boil. Stop the aperture at the top, and after 8 or 10 minutes, which time should be allowed for the vapour to expel the atmospheric air, which otherwise would cause an explosion, apply the flame of a lamp to the pierced lines. In an instant all the lines will be covered with flame, which will continue till the spirits are exhausted. 83. To produce flame of various colours. This may be effected by mixing certain substances with burning alcohol, or by applying them with the point of a penknife to the wick of a burning lamp or candle. Thus a beautiful rose or carmine-coloured flame may be produced by muriate of strontia. This is prepared by dissolving carbonate of strontia in muriatic acid, and evaporating it to dryness. The preparation for an orange colour is muriate of lime, a solution of marble in muriatic acid evaporated to crystallization, which should be exposed to a moderate heat till it is deprived of its water of crystallization and falls to powder. A fine green tinge is produced by acetate of copper, or boracic acid, which last is procured by adding sulphuric acid to a solution of borate of soda in hot water till it has a sensibly acid taste. As it cools, the boracic acid is deposited in crystals on the sides of the vessel. Camphor gives to flame a blue colour, and nitrate of strontia, prepared the same as muriate, a purple. A brilliant yellow may also be produced by muriate of soda. Any of these preparations being reduced to powder may be ignited with 3 or 4 times their weight of alcohol, which should be previously warmed, and if the vessel that contains it be kept heated also, the combustion will be the more brilliant. End of section 21. Section 22 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. A select collection of valuable and curious arts and interesting experiments by Unknown. 84. To make skyrockets and fire wheels. Grind and mix together, dry, 1 pound of gunpowder, 2 ounces of sulphur, 2 ounces of nitrate of potass, and 4 ounces of newly burnt charcoal. Then make several strong paper cases or cartridges by wrapping some strong paper, being moistened with paste, 15 or 20 times round a mould made of wood, which may be 1 inch in diameter and 10 inches in length. One end of this mould must be made smaller, being only 1/4 of an inch in diameter for the space of an inch of its length. The paper must be drawn up close round this neck and strongly bound with twine, being thus brought to a shape similar to the neck of a vial. This neck is called the choke of the cartridge. take the paper from the mould and proceed in the same manner with another. When a sufficient number of cartridges are thus made and dry, place one of them in a socket which it will fill up closely, and then fill the cartridge with the above described compound powder, which must be thrown into the cartridge in small quantities, and each several quantity must be rammed or beat down very hard with a suitable sized rammer and mallet. In filling the cartridge, small quantities of any of the flame colouring preparations described in the preceding article may be added occasionally. When the cartridge is nearly full, some small balls of cotton dipped in spirits of turpentine may be added to produce the appearance called stars. These also may have some muriate of strontia or boracic acid strewed on them. Then place a circular piece of thick pasteboard on the materials in the cartridge, having a small hole through it, communicating with the powder below. Lay upon this 1/2 ounce of fine gunpowder, and fold the paper down upon it from all sides, cementing the folds firmly with glue, thus giving the end of the cartridge a conical form. Then bore a hole about 2/3 of the length of the cartridge from the choke with a gimlet or bit. Fill this hole, which must be as large as the choke, but tapering towards the other end, with fine gunpowder to the choke, and fill the choke with the compound, the outside of which may be moistened a little, the better to keep it in its place. Finish the others in the same manner, and keep them in a warm, dry place till used. They are then to be lashed firmly to the end of a light pine rod, with the choke towards the opposite end. The length of the rod should be about 9 times that of the cartridge. The rocket then being elevated by the rod, and being ignited at the choke, the compound inside burning intensely acts upon the air and causes it to ascend. The cartridges for fire wheels are prepared in the same manner, but are generally smaller, and instead of being lashed to a rod, they are lashed to the arms of a wheel, in such manner that a violent rotary motion is produced by their combustion. 85. To produce detonating balloons. Moisten and compress a bladder till no air remains in it, and tie the neck of it upon a perforated cork. Set the cork in a flask containing the materials for producing hydrogen gas, C9. Thus convey into the bladder a quantity of the gas, and then remove the cork to another flask, containing 2 or 3 ounces of black oxide of manganese moistened with sulphuric acid, sufficient to form with it a soft paste. Apply the heat of a lamp, and oxygen gas will be evolved, and will also rise through the neck of the flask. In this manner convey into the bladder nearly half as much oxygen gas as it previously contained of hydrogen. Then tie the stem of a tobacco pipe in the neck of the bladder, and dip the bowl of the pipe in a solution of soap in water, soap suds, and compress the bladder a little, so as to swell a bubble from the bowl of the pipe. Shake off the bubble, which being lighter than atmospheric air will naturally rise or float horizontally in the air. If the flame of a candle be brought in contact with one of these balloons or floating bubbles, it will explode with a violent detonation, resembling the report of a pistol. If this compound gas be forced into the water so as to form several bubbles on the surface, and flame be then applied to them, a volley of explosions will be the result. Caution is requisite in these experiments, that the fire be not communicated to the bladder, as such an explosion might not be safe. 86. To prepare a phial that will give light in the dark. Fill a small phial about 1/3 full of olive oil. Add to this a piece of phosphorus equal to 1/10 of the weight of the oil. Cork the phial and wrap it in paper to exclude the light, and set it or suspend it in a warm place, but where the heat may not be equal to that of boiling water, till the phosphorus appears to be dissolved. This phial may be carried in the pocket, and whenever the cork is started in the night, the phial will evolve light enough to show the hour on a watch. 87. To make a person's face appear luminous in the dark. Prepare some phosphorized oil, as directed 27, and rub it over the face. This oil, though it appears luminous in the dark, has not power to burn anything, so that it may be rubbed on the face or hands without danger, and the appearance thereby produced is most hideously frightful. All the parts of the face that have been rubbed appear to be covered with a luminous bluish flame, and the mouth and eyes appear as black spots. The luminous appearance may also be repeatedly heightened by the friction of a handkerchief being rubbed over the luminous part. End of section 22.
Section 23 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Stacy M. A select collection of valuable and curious arts and interesting experiments by Unknown. 88. To freeze water in warm weather. Draw a thread through a small glass tube. Close one end and then fill the tube with water. Mix together equal parts of nitrate of ammonia and water, and immerse the tube in this mixture. The water in the tube will be frozen immediately and may be drawn out by the thread. The same effect may be produced by a mixture of 1 part muriate of ammonia, 1 part nitrate of potass, and 3 parts of water. For these experiments, the above-mentioned salts should be fresh, dry, and finely pulverized previous to mixing. The mixture should be made in a tin vessel that is coated inside with beeswax and has a flannel wrapper round the outside, and the tube should be immersed quickly as soon as the ingredients are mixed to produce a greater or intense degree of cold. A small vessel of water is first set in one of those freezing mixtures till it becomes very cold, and then the due proportion of the salts are added to that, and the tube, etc., immersed in it. The water in the tube may also be frozen by continually bathing the outside of it with sulfuric ether. The evaporation of the ether carries off the caloric of fluidity, and the water congeals. 89. To change the colors of animals. Any black or dark-colored spots on some animals, especially horses, may be effectually changed to white by means of any substance that will chafe or blister the skin. Thus a white spot of any shape may be produced on a black horse by shaving off the hair from the part that is to be thus marked, and applying a plaster of Spanish flies, or of quicklime moistened with vinegar. This plaster must be cut to the size and form required for the mark, and must be kept bound on till the skin is blistered, or nearly so. The next coat of hair will infallibly be white. White spots can be changed to black or brown only by means of oils or grease. Bacon fat has been recommended for this purpose, but if the oil or fat of a bear can be procured, it will prove more efficacious, as this fat is well known to have a remarkable tendency to darken the color of animals and even complexions. But either of these, and in fact many other kinds, will answer this purpose if properly applied and frequently repeated. 90. To give leather a beautiful metallic luster. Levigate 1 ounce of soft lead-colored plumbago, and an equal quantity in bulk of lampblack in a gill of alcohol. Then add half an ounce of loaf sugar, moistened with water, and grind all together. The leather must first be brushed over smoothly with this composition, and when dry it must be brushed hard and quickly with a dry smooth brush, or may be rubbed with a piece of woolen cloth. This blacking will be found useful for some ornamental purposes, but may be rather too brilliant for boots and shoes. This composition, however, may be mixed occasionally with other kinds of blacking, and will tend to increase their brightness. End of section 23.
Section 24 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Jennifer Beckett Wood. A select collection of valuable and curious arts and interesting experiments by Unknown. 91. An easy method of extracting the essence of roses. Take the leaves of roses and pound or bruise them. Then stratify them with an equal weight of muriate of soda in a glazed earthen vessel. When thus filled to the top, cover it well and set it in the cellar, and let it remain at rest a month or more. Afterwards, strain off the essence therefrom through a strong cloth by pressure.
The essence thus procured is quite equal, if not superior, for culinary purposes, to that which is procured by distillation. 92. To prepare various kinds of essences. The manner of extracting the essential oils, being attended with considerable expense of preparations, of stills, etc., a particular description of the process would not, it is presumed, be sufficiently interesting to warrant its insertion. But the manner of reducing the oils to the state in which they are more generally sold, and is distinguished by the term essences, is as follows. To half a pint of alcohol, add 1 ounce of any of the essential oils, lemon, cinnamon, foxberry, peppermint, etc., and shake them together. Set the mixture in a warm place for a few minutes, and if then any opaque or milky appearance remains, a little more alcohol must be added. When this has become clear, it may be diluted occasionally with new rum. The essences of foxberry and cinnamon are coloured with a few drops of tincture of red saunders, and the essence of lemon with tincture of turmeric. 93. To prepare soda water. Only 2 articles are requisite for this preparation, one of which is supercarbonate of soda, or of potass, sal aeratus, and the other is citric or tartaric acid. The supercarbonates are formed by passing a stream of carbonic acid gas, which is produced by adding muriatic acid to pulverized marble, through a solution of soda or potass in water, then evaporating till it crystallizes. Citric acid is prepared from the juice of lemons, and tartaric acid, which is more generally employed, is procured from supertartrate of potass. But these being common articles of commerce, a more minute description of the process of preparing them may not, in this place, be expedient. The compound, called soda powders, consists of about 10 grains of either of the supercarbonates, with an equal quantity of either of the acids in each paper. This compound being dissolved in a glass of water, produces violent effervescence, and if drank off at the time, gives the water a smart and agreeable acid taste. The salt and acid, if mixed in powder, must be kept perfectly dry, otherwise they would act on each other and soon be spoiled. On this account they are frequently prepared in separate papers and sold by sets. Soda water is similarly prepared on the larger scale, the salts and acid being put into a cask of water, which is so confined that the carbonic acid can have no other vent than by forcing out the water through a pipe fixed for the purpose with a tube, etc. End of section 24.
Section 25 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Clark Essman. A select collection of valuable and curious arts and interesting experiments by Unknown. 94. To produce metallic trees. Process 1. Mix 1 part of a saturated solution of nitrate of silver with 20 parts of pure water and pour the mixture upon 2 parts of mercury in a phial. After some time, the mercury being left standing quietly, the branches and the figure of a tree formed of brilliant silver will appear to grow from the mercury in a very beautiful manner, the silver in solution being thus robbed of its oxygen by the metallic mercury and consequently precipitated. 95. Process 2. Dissolve 2 drachms of acetate of lead in 6 ounces of water, filter the solution, and pour it into a clean, wide phial. Then suspend a granule of zinc by a thread or wire fastened to the cork of the phial in the middle of the solution and place the phial where it will not be disturbed. After a few hours, the lead, being deoxidized by the zinc, will be precipitated on the zinc in the shape of leaves, which will have a very brilliant appearance. 96. To tin copper by boiling. Boil half a pound of granulated tin and 6 ounces of supertartrate of potass in 3 pints of water. When they have boiled half an hour, put in any piece of copperware and continue the boiling 15 minutes longer. The copper may then be taken out and will have been handsomely coated with tin. 97. A metal that will melt in hot water. Melt together 8 parts of bismuth, 5 of lead, and 3 of tin. This alloy, though hard and brilliant when cold, is so easily fusible that it may be melted on a paper being held over the flame of a candle. Teaspoons may be made of this compound metal, which may be melted by putting them in a cup of hot tea. End of section 25.
Section 26 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Jennifer Beckett Wood. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. 98. Illustration of calico printing. It frequently occurs that substances of different colours, or even without colour, by coming in contact, produce colours very different from that of either of the ingredients when separate. Thus, if a sheet of paper be striped in one direction with a hair pencil dipped in a solution of subcarbonate of potass, and then crossed with a solution of sulphuric acid diluted with 5 times as much water, it will be colourless. But dip it in a mixture of a weak solution of sulphate of iron, an infusion of nut galls, and it will instantly become a beautiful plaid, the ground being purple, striped one way with black, and crossed with white. If a similar paper be striped with subcarbonate of potass, and crossed with infusion of galls, and afterward dipped in a solution of sulphate of iron, it will become purple, yellow, black, and white. Dip a piece of white calico in a cold solution of sulphate of iron and let it dry. Then imprint any figures upon it with a strong solution of colourless citric acid, and let this dry also. If the piece be then well washed in warm water, and afterwards boiled in a decoction of logwood, the ground will be dyed either a slate or a black colour, according to the strength of the metallic solution, while the printed figures will remain beautifully white. Stain some parts of a sheet of paper a purple brown, with a mixture of infusion of galls and sulphate of iron. Stain other parts green with a mixture of tinctures of turmeric and litmus. Stain other parts purple with juice of red cabbage. Other parts red with tincture of litmus and muriatic acid. Other parts yellow with tincture of turmeric. Wash the remainder of the sheet with a solution of sulphate of iron, which will remain white. Then print or draw with a camel hair pencil any figure or figures on every part of the paper with a solution of subcarbonate of potass. On the purple brown, the figure will be black. On the green, it will be purple. On the purple, it will be green. On the red, it will be blue. On the yellow, red. And on the white, it will take on a yellow colour. Thus the figure will appear in colours different from the ground in every part. Immerse a piece of white cotton in a solution of sulphate of iron, it will remain white. Dip another piece in tincture of turmeric, it will take a yellow. Wet another piece with juice of red cabbage, containing also a few drops of muriatic acid. It will be red. Dye another piece green by immersing it in a mixture of tincture of turmeric and litmus, and another purple by a mixture of infusion of galls and sulphate of iron. Let them dry. Then immerse them all together in a solution of subcarbonate of potass. The white will be changed to a yellow, the yellow to a red, the red to green, the green to purple, and the purple to black, and it is not improbable that some black might be materially changed or bleached by the same simple solution. 99. To prepare an imitation of gold bronze. Melt 2 ounces of tin and mix with it 1 ounce of mercury. When this is cold, pulverize it and add 1 ounce of muriate of ammonia and 1 ounce of sulfur and grind them all together. Put the compound in a flask and heat it in a clear fire, carefully avoiding the fumes, till the mercury sublimes and rises in vapour. When the vapour ceases to rise, take the glass from the fire. A flaky gold-coloured powder will remain in the flask, which may be applied to ornamental work in the manner of gold bronze, of which it is a tolerable imitation. End of section 26.
Section 27 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Larry Wilson. A select collection of valuable and curious arts and interesting experiments by unknown. 100. To procure the exhilarating gas. Put a quantity of nitrate of ammonia into a flask, and apply the heat of a lamp, which must be gentle and well regulated. The salt will in a short time liquefy, and must then be kept quietly simmering, avoiding violent ebullition. The gas will be evolved, and rise through the neck of the flask, and may be collected in a bladder containing a small quantity of water, and should be allowed to stand a few hours, and shifted into another bladder or silk-varnished bag before it is used. Though this gas is not fitted to support life, yet it may be respired for a short time, and the effects produced by it upon the animal frame are its most extraordinary properties. The effects of this gas are in general highly pleasurable, and resemble those attendant on the agreeable period of intoxication. Exquisite sensations of pleasure, an irresistible propensity to laughter, a rapid flow of vivid ideas, a strong incitement to muscular motion, are the ordinary feelings produced by it. And what is exceedingly remarkable is that the intoxication thus produced, instead of being succeeded by the debility subsequent to intoxication by ardent spirits, does, on the contrary, generally render the person who takes it cheerful and high-spirited for the remainder of the day. 101. Construction of a galvanic pile or battery. Procure 50 or more thin plates of copper, and the same number of plates of zinc, all of which may be about the size of a dollar, but not so thick. The copper and zinc plates may be either cast in molds, or may be cut out of rolled plates of the metals. In addition to the plates of copper and zinc, it is necessary to be provided with an equal number of pieces of woolen cloth rather smaller than the metallic plates in size. Let these be soaked in a solution of muriate of soda till they have thoroughly imbibed it. Then take them out of the solution and squeeze them gently to force out the superabundant water. Then, having provided a circular piece of wood, rather larger than the plates, cover it with tin foil, and on this lay a plate of zinc, upon that a plate of copper, and then a piece of moistened cloth, next to a plate of zinc, etc. Continue this arrangement of zinc, copper, and cloth till all the pieces that have been provided are laid on. As the pile began with zinc, it must be concluded with copper. This pile may be braced occasionally with strips of glass to prevent it being overthrown. Fix the end of a piece of metallic wire in contact with the base, and lay the end of another piece upon the top of the pile. If thus the opposite ends of wire be brought in contact with each other, or if they are connected to any conducting body, so as to form a circuit of conductors, the pile will afford a constant and powerful current of galvanic fluid through them for many hours. If the hands be moistened and one of them applied to each of the wires, a shock will be received. Gold and other metals have been melted, and even burnt, and potash, soda, and lime have been reduced to their respective metallic states by being made to form part of a galvanic circuit. When the pile is not in use, it should be taken down, which will preserve it from wear, and the plates will require to be cleansed occasionally, which may be easily done by diluted muriatic acid. 102. Construction of the oxyhydrogen blowpipe. This useful instrument consists of a cubical vessel made of tin plate, being from 10 to 20 inches in length, breadth, and height. The inside is divided into 4 equal apartments by 2 partitions crossing each other in the center. The 2 front apartments are covered at the top, and each of them have a tube affixed in the front side, near the top with a stopcock. The other apartments are open at the top, and communicate with those in front by a small aperture near the bottom of each. These apartments being all filled with water, those in front are filled, the one with oxygen and the other with hydrogen gas, which is done by forcing the gases into them through the tubes in front, which causes the water to recede through the aperture at the bottom, and consequently part of the water is forced over the top of the other apartments, or rather may run off through small tubes fixed for the purpose, near the top, similar to those in front. When the front apartments are filled with the gases, which may be known by the bubbling in the others, the tubes are stopped and 2 leaden pipes are fixed in them, the opposite ends of which are so placed that the 2 streams of gas, when expelled from the gas holders, may come in contact very near the end of the pipes. When the tubes are opened, the pressure of the water will expel the gases and will consequently settle and must be replenished, so as to keep the apartments nearly full. When the 2 streams of gas are ignited at the point of contact, a flame is produced of sufficient intensity to burn gold, silver, copper, or tin with a very brilliant combustion. 103. To make a dry phosphorescent powder. Take some thick oyster shells, wash them, and calcine by keeping them red hot in an open fire for half an hour. Then select the clearest and whitest parts and reduce them to powder. Mix 3 parts of this powder with 1 of the flour of sulphur. Fill a crucible with this compound, pressing or beating it down as hard and solid as may be, without breaking the crucible. Set the crucible in the fire, and heat it moderately at first, but increase the heat gradually for an hour, in which time it must approach nearly to a white heat. Then let it cool, and again select from the mass the whitest and purest parts, which must be preserved in a phial with a glass stopper. This powder has the peculiar property of imbibing the rays of the sun in the daytime and emitting them again in the night; or, if the phial containing it be exposed for a few minutes to the direct rays of the sun, and then carried into a dark room, light enough will be evolved to render it distinctly visible. 104. Curious experiment of precipitation. Set 5 glasses on the table, and nearly fill one of them with a solution of sulphate of iron, and another with a solution of sulphate of copper, a third with a solution of nitrate of bismuth. Pour into the fourth a solution of nitromuriate of cobalt, and into the fifth a solution of acetate of lead, or sulphate of zinc. These liquid solutions may all be diluted so as to be colorless. Then pour into each glass a few drops of a colorless solution of prussiate of potasse. The contents of the first glass will be instantly changed to a full blue color, those of the second to a reddish brown, those of the third to a yellow, the fourth to a green, and the fifth to a white. Thus 5 distinct colors will be given by the addition of 1 colorless solution. End of section 27.
Section 28 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Jennifer Beckett Wood. A select collection of valuable and curious arts and interesting experiments by Unknown. 105. To make a beautiful soft glass for jewelry, take 6 ounces of clean, fine white sand, 3 ounces of red lead, 3 ounces of pure subcarbonate of potass, 1 ounce of nitrate of potass, half an ounce of borate of soda, and 2 drachms of arsenic. Mix and pound them all together. Put the compound in a crucible and set it in a common fire, often stirring it with an iron rod till it is well melted and becomes transparent. This compound will liquefy very easily without any great heat if the sand is fine, which sometimes requires to be ground or pounded in a glass or flint mortar, and if it be kept melted a while will become beautifully transparent and may be cast or blown in the manner of other glass. This glass may be changed to a red or ruby color by adding and fusing together with it a small quantity of finely powdered precipitate of gold, gold precipitated from solution in nitromuriatic acid by the addition of tin. It may be also changed to blue by the addition of zaffre, an ore of cobalt, and magnesia. A green color may be given by a precipitate of copper, and yellow by calcined iron, and white by calcined bones. This subject is treated of largely in the Handmaid of the Arts, to which, for further information on the subject, the reader is referred. 106. Composition of various kinds of glass. The best flint glass is composed of 129 pounds of white sand, 50 pounds of red lead, 40 pounds of subcarbonate of potass, 20 pounds of nitrate of potass, and 5 ounces of magnesia. The best crown glass is composed of 60 pounds of white sand, 30 pounds of subcarbonate of potass, 15 pounds of nitrate of potass, 1 pound of borate of soda, and half a pound of arsenic. The composition of common green window glass is 120 pounds of white sand, 30 pounds of subcarbonate of potass, 60 pounds of wood ashes, 20 pounds of muriate of soda, and 5 pounds of arsenic. The composition for looking glass plates is 60 pounds of clean white sand, 25 pounds of purified subcarbonate of potass, 15 pounds of nitrate of potass, and 7 pounds of borate of soda. Common green bottle glass is made from 200 pounds of wood ashes and 100 pounds of sand. The materials for making glass is first reduced to powder, then mixed and exposed to a strong heat in suitable pots and furnaces till the whole mass liquefies and becomes thoroughly commixed and transparent. 107. Composition of various alloys. Brass is composed of 2 parts of copper to 1 of zinc, or copper and calamine, an ore of zinc, equal quantities. Pinchbeck consists of from 5 to 10 parts copper and 1 of zinc. Bell metal is composed of 3 parts copper and 1 of tin. Gun metal, 9 parts copper and 1 of tin. Tombac, 16 parts copper, 1 part zinc, and 1 of tin. The composition of pewter is 7 pounds of tin, 1 of lead, 4 ounces of copper, and 2 of zinc. That of type metal is 9 parts lead, 2 parts antimony, and 1 of bismuth. Solder, 2 parts of lead with 1 of tin. Queen's metal, 9 parts of tin, 1 of bismuth, 1 of antimony, and 1 of lead. Jewel gold is composed of 25 parts gold, 4 parts silver, and 7 parts fine copper. In forming metallic compounds or alloys, it is proper to melt such of the ingredients as are the least fusible first, and afterwards add the others, stirring them briskly till they are thoroughly commixed. End of section 28.
Section 29 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Clark Essman. A select collection of valuable and curious arts and interesting experiments by Unknown. 108. To produce various kinds of gas. To 3 or 4 ounces of pulverized chalk or marble moistened in a flask, with an equal quantity of water, add 1 ounce of sulfuric acid. Carbonic acid gas will be evolved in abundance and will rise through the neck of the flask and may be conducted by pipes to any proper receiver. Instead of the marble or chalk, substitute granulated zinc. In this case, hydrogen gas will be evolved, but this may require a larger proportion of water. Pour sulfuric acid upon a similar quantity of dry muriate of soda. Muriatic acid gas will be rapidly evolved. Proceed in the same manner with a similar quantity of black oxide of manganese. Apply the heat of a lamp, and oxygen gas will be produced. Put into the flask 2 or 3 ounces of lean beef cut into small pieces. Pour over them 1 ounce of nitric acid diluted with 3 ounces of water. Apply the heat of a lamp, and nitrogen gas will be liberated. Powder separately equal quantities of muriate of ammonia and newly burnt lime. Put them together into a flask and apply gentle heat. Ammoniacal gas will be evolved. Pour an ounce of nitric acid, diluted with 5 times its weight of water, upon 1 ounce of shreds or turnings of copper. Nitrous gas will be rapidly evolved. Grind 3 parts of muriate of soda with 2 parts of black oxide of manganese. Introduce this mixture into the flask and add 2 parts of sulfuric acid diluted with an equal quantity of water. Apply a gentle heat and chlorine gas will be evolved. Note: when either of the last mentioned gases are produced, great caution is requisite that they do not escape into the room in any considerable quantity, as their action on the lungs is exceedingly injurious. 109. Various chemical tests. When water is suspected to hold any foreign substance in solution, various means may be used to detect and ascertain the quality of the substances combined. Thus, acids may be detected by immersing in the water a slip of litmus colored paper, which, if acid be present, will be changed to red. In the same manner, alkalis may be detected by a strip of turmeric yellow paper, which will also be changed to red by alkalis. These tests are sensible to the presence of an acid or alkali in the proportion of 1 to 10,000. Iron may be detected by a drop of infusion of galls, which will give to the water, if iron be present, a brown tinge. A drop of sulfuric acid precipitates barytes in the form of a white powder. Clear transparent lime water, water in which lime has been slaked and then suffered to settle, will indicate the presence of carbonic acid by a milky whiteness. On the same principle, a solution of supercarbonate of potass will detect lime. A few drops of nitrate of silver will instantly discover muriatic acid by a white flaky precipitate. Muriatic acid, consequently, is a good test for silver. Acetate of lead in solution is a test for sulfurated hydrogen, which occasions a precipitate of a black color. Nitrate of mercury is an excellent test for ammonia, 1 part of which, with 30,000 parts of water, is indicated by a blackish yellow tinge on adding the test. Liquid ammonia is a very sensible test for copper, with which it strikes a fine blue color. Nitromuriate of gold will discover the presence of tin by a beautiful purple precipitate. Nitromuriate of tin is on the same principle an excellent test for gold. 110. To produce a picture instantly in a variety of colors. Paint any picture on paper in the usual way, only instead of colors, use the following substitutes. For green, use a solution of nitromuriate of cobalt. For blue, a solution of sulfate of iron. For yellow, a solution of nitrate of bismuth. And for brown, a solution of sulfate of copper. Any of these solutions may be more or less diluted as the respective parts of the picture are to be light or dark, but none of them must be strong enough to color the paper. This picture is invisible, but when it is required to appear, the paper may be tacked up on the wall, and having a glass of the transparent solution of prussiate of potass, which by sight cannot be distinguished from clear water, dashed suddenly upon it, the picture will instantly appear in its full colors. A similar effect may be produced by drawing the picture with infusion of galls and subcarbonate of potass. This is revived by a solution of sulfate of iron, and appears in a yellow and a brown color. End of section 29.
Section 30 of A Select Collection of Valuable and Curious Arts and Interesting Experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betty B. A Select Collection of Valuable and Curious Arts and Interesting Experiments by Unknown. 111. A Cheap Imitation of Silver Bronze. Put into a crucible an ounce of pure tin and set it on a fire to melt. When it begins to melt, add to it an equal quantity of bismuth, and stir the mixture with an iron rod till the whole is entirely melted and incorporated. Take the crucible then from the fire, and after the melted composition has become a little cooler, but while it is yet in a fluid state, pour into it gradually an ounce of mercury, stirring it at the same time, that the mercury may be thoroughly conjoined with the other ingredients. When the whole is thus commixed, pour the mass out of the crucible on a stone, where as it cools it will take the form of an amalgam, or metallic paste, which will be easily bruised into a flaky powder, and may then be applied to sized figures in the manner of gold or silver bronze, or may be tempered with gum water, and applied to the work with a brush or camel hair pencil, and if properly secured with varnish or lacquers will be even more durable than either silver leaf or silver bronze. 112. To make crayons of various colors. Crayons or pastels consist of various colored pigments or paints, formed into sticks or rolls for the purpose of drawing and shading with them in the manner of lead pencils. But that they may be of uniform texture or hardness, different ingredients and materials require some variation in the management. To make white crayons, nothing more is requisite than to mix superfine or refined whiting with alcohol to the consistence of soft putty, form it into rolls of a convenient length and size, and let them dry. Or the whiting may be mixed with water and a sufficient quantity of burnt or calcined sulphate of lime, to give the crayons a sufficient degree of hardness when dry. A great variety of elegant light colors may be formed by adding to the whiting prepared as above, small quantities of any of the colored pigments. The most proper colors for crayons are lamp black, Prussian blue, burnt umber, burnt terra de sienna, red ochre, vermilion, lake, rose pink, chrome yellow, yellow ochre, and mineral green. Many other handsome greens are formed by mixing chrome yellow with Prussian blue, varying the proportions, and purples are produced by mixing rose pink or lake with blue. Prussian blue and lake being each naturally of a binding nature, require only to be ground in water, but red ochre and vermilion should be ground in alcohol, or may have some quantity of the sulphate of lime mixed with them. Any of these colors may be mixed in any proportion with whiting or with each other, each compound having a sufficient proportion of the sulphate of lime to give it a proper degree of hardness and strength when dry. The proper length for crayons is from 2 to 3 inches, and the size about the same as that of a tobacco pipe stem. It is customary in making crayons to have at hand a large piece of chalk with a plain surface, on which to lay the crayons as soon as they are rolled. The chalk absorbs a part of the moisture, which makes them dry the sooner and without cracking. 113. To make hard sealing wax of various colors. Take of gum shellac and rosin each 2 ounces, and of gum mastic 1 ounce. Reduce them to powder, and mix and melt them together over a gentle fire. Then, if a red color is required, add to the mixture 1 ounce of fine vermilion. For a black color, add half an ounce of a mixture of lamp black with rum. For a blue, half an ounce of white lead with 1/4 of an ounce of Prussian blue, which should be previously ground together dry. To give a green color, add finely ground verdigris. A yellow is produced by chrome yellow or gamboge, and white by adding pure white lead to the mixture. When the desired color is formed by the mixture and incorporation of any of the above mentioned coloring ingredients, take out a part of the mixture sufficient to form a stick or roll of the usual size, and roll it between 2 smooth metallic plates, which should also be previously warmed to prevent the wax from becoming too hard. When the stick is reduced to a proper size, flatten it a little and let it cool. Proceed in the same manner with the rest of the composition. Afterward hold each stick severally over a fire of charcoal, turning it quickly till the surface of the wax is completely melted, by which means the sticks will have acquired a very smooth and shining polish at the surface, which they will retain when cold again. If a softer wax is required, A small quantity of beeswax and of linseed oil may be added to the above composition, or may be substituted in the place of the gum mastic. 114. The art of manufacturing paper hangings. This business, which has been usually, though improperly termed paper staining, consists principally in stamping or painting various figures in water colors on paper. The paper for this purpose is formed into long strips or rolls by pasting the edges of several sheets together. The edges of the sheets should not lap on each other more than half an inch, and the usual length of a roll is about 9 yards. These rolls are first painted plain with a large brush. The paint is composed of refined whiting with some coloring ingredient, being ground in water and tempered with a sufficient quantity of glue to prevent it from rubbing off. When a new design or figure is to be introduced, several colors are prepared, i.e., as many as are required in such design, and with these the design is painted on a sheet of paper. The paper is then laid on a smooth birch or maple board, and such parts of the paper as contain the color that was last applied in the drawing, which is usually the white, are completely cut out with a sharp penknife, and the parts thus cut out are pasted down upon the board immediately in the places and positions they occupied in the design. The sheet is then removed to another board, and another color is cut out in the same manner. Thus the several colors are distributed in their proper arrangements on as many different boards. Each board is then cut away with chisels and gouges to the depth of 1/4 or 1/8 of an inch, in every part except where the pieces of paper are fixed. These boards or prints are supported by other thin pieces, which are fixed firmly on the backs of them by screws, in such a manner that the grain of one crosses that of the other and thus prevents their warping. They have also cleats or pins attached to them which serve as handles. A trough is provided, a little larger than the prints, of 1 inch in depth, and having a smooth bottom, on which is laid 3 or 4 pieces of fine flannel or cassimere, each of which is at least as large as the prints. Then some of the color with which the first part of the design was painted is spread upon the cloth with a brush, and upon this the print containing the corresponding parts of the figure is pressed, the pieces of paper having been previously scraped off. The print being thus charged with the color is placed upon one end of a roll of the prepared paper, which is laid on a table for that purpose, and is pressed down hard by a lever or screw. It is then returned to the trough and again charged with the color, and again impressed on the paper at a proper distance above the other impression. In this manner several rolls are printed with one color. Then the next color in the design is applied to the paper in the same manner by another print, a third color by a third print, and so on till the paper is completely printed with every color in the design, each in its proper place. These prints should be washed and kept dry for future use. A variety of figures may be produced with the same print by varying the colors. 115. To make elastic blacking for leather. Dilute 1 ounce of gum asphaltum with a pint of spirits of turpentine, in the manner described at 51. Put this into a flask and add 1 ounce of gum elastic cut into very small pieces, and half an ounce of gum shellac previously reduced to powder. Suspend the flask, unstopped, over a fire of charcoal, or set it in a sand bath where it may boil gently till this quantity is reduced to a gill. Then strain it through a flannel, and when nearly cold, bottle and cork it. The leather should be thoroughly blackened with some liquid blacking, and waxed over slightly with beeswax before the elastic blacking is applied. If the blacking should be too thick, it may again be diluted with spirits of turpentine. It should be warmed when applied, and the work may require several coats, and a considerable time for each to dry. Any of the above mentioned gums may also be dissolved in sulphuric ether, and thus produce a fine drying varnish, but the preparation is much more difficult, as the volatile nature of the ether will not admit of much heat whereby to facilitate the solution. 116. Sundry experiments. Rub together a little dry powdered alum and acetate of lead. Both will become fluid. To a saturated solution of muriate of lime, add a saturated solution of subcarbonate of potass, both transparent liquids. The mixture will be nearly solid. Rub together a little pure white calomel, sublimed mercury, and pure white ammonia, being moistened. Both will become intensely black. Fill a flask nearly half full of water and apply heat till it boils. Take it from the fire, and when it has done boiling, cork it. Pour cold water upon the flask, and the water inside will recommence boiling. Fill a glass with water, and lay a piece of paper upon the top of it. Place your hand upon the paper and invert the glass. The hand may be removed and the glass may be suspended in that position by a thread, and the water will not be spilled. Expose a piece of ice to the action of cold muriatic gas. The ice will be instantly melted. Drop a piece of phosphuret of lime into a glass of water. Bubbles will soon rise, and on reaching the surface of the water will spontaneously explode. Apply the end of a roll of brimstone to a hot bar of iron. A part of the iron will be instantly melted and will fall. Write with diluted sulphuric acid on paper that has been colored brown by a mixture of sulphate of iron and infusion of galls. The writing will be white. Moisten the under lip and lay upon it a piece of silver money, not less than a 20-cent piece, with the edge of it beneath the tongue. Lay a piece of zinc of nearly an equal size upon the tongue and bring the edges of the pieces of metal into contact. You will instantly drop the money. End of section 30.
Section 31 of a select collection of valuable and curious arts and interesting experiments. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Larry Wilson. A select collection of valuable and curious arts and interesting experiments by Unknown. Appendix. Catalogue of the various articles mentioned in the preceding pages, with the prices, explanations, etc. Acetate of cobalt, produced by digesting the oxide of cobalt in strong vinegar. Acetate of lead, sugar of lead, procured by dissolving white lead in vinegar and evaporating, 6 cents per ounce. Acetic acid, vinegar concentrated by distillation, 25 cents per pint. Alcohol, rectified spirit of wine, 25 cents per pint. Alum, sulphate of alumine and potash, 3 cents per ounce. Ammonia, hartshorn, a volatile alkali, 12 cents per ounce. Antimony, a dark porous metal, 6 cents per ounce. Beeswax, a yellowish resinous substance procured from honey or honeycombs, 6 cents per ounce. Bismuth, tin glass, a reddish white metal, 12 cents per ounce. Boracic acid, procured by adding sulphuric acid to a hot solution of borax. The acid crystallizes, 100 cents per ounce. Brazil wood, redwood, 6 cents per pound. Borate of soda or subborate of soda, borax, is brought from the East Indies in an impure state called thincal, 6 cents per ounce. Burnished gold size and burnishers may be had of Bittle and Cooper, Pemberton's Hill, Boston. Price various. Camphor, obtained from a species of laurel tree, 12 cents per ounce. Carbonate of copper, French green, produced by adding a solution of supercarbonate of soda to a hot solution of sulphate of copper, 50 cents per pound. Carbonate of lead, white lead, is formed by exposing thin sheets of lead to the vapor of vinegar, after which they abstract the carbonic acid from the atmosphere, 16 cents per pound. Carbonate of strontia, a native mineral, 50 cents per ounce. Carbonate of lime, marble chalk, a native earth. Chlorate of potash, procured by passing a current of chlorine gas through a solution of pearl ash, 100 cents per ounce. Chrome yellow, A pigment is formed by the combination of a metallic substance with the chromic acid. 12 cents per ounce. Cobalt (Zaffre), a metal of reddish gray color. When exposed to a gentle heat it becomes oxidized and takes the form of a black powder. 50 cents per ounce. Citric acid, procured from lemons, limes, etc. 75 cents per ounce. Calomel, white sublimate of mercury. 20 cents per ounce. Dragon's blood, a red mucilage extracted from a plant. 10 cents per ounce. Fluate of lime, fluorspar, is found in abundance in Derbyshire, England. Its acid constituent has the peculiar property of dissolving glass. 50 cents per pound. Frankfurt Black, which takes its name from Frankfurt in Germany, is manufactured from the lees of wine. 12 cents per ounce. Gamboge, a yellow opaque gum or mucilage. 16 cents per ounce. Glue, gelatin, a jelly procured from skins of animals. 25 cents per pound. Gold bronze, gold in fine powder. 75 cents per pennyweight. Gold leaf, thin laminas of gold. 45 cents per book. Gum arabic, a mucilaginous substance that exudes from certain trees in Arabia. 6 cents per ounce. Gum asphaltatum, a bitumen or mineral pitch. 8 cents per ounce. Gum copal, a hard transparent resin. 40 cents per pound. Gum elastic, Indian rubber, caoutchouc, exudes from the trees in the West Indies. 8 cents per ounce. Gum sandarek, a resin similar to rosin, but much harder. 100 cents per pound. Gum shellac, a compound, resinous substance procured from the nests or cells of an insect. 6 cents per ounce. Gum mastic, a hard, transparent resin. 100 cents per pound. Isinglass, a kind of transparent glue procured from various kinds of fish. 25 cents per ounce. Lake, drop lake, a rose-colored pigment prepared from Brazil wood. 200 cents per ounce. Lead, a brown heavy metal. 12 cents per pound. Lime, an oxide of calcium, is procured by calcining limestone, marble, or chalk. Linseed oil is expressed from ground flaxseed. 15 cents per pint. Litharge, gold litharge, an oxide of lead. 4 cents per ounce. Litmus, a blue coloring vegetable. 10 cents per ounce. Mercury, quicksilver, a metal that remains fluid in the common temperature of the atmosphere. 8 cents per ounce. Muriate of ammonia, sal ammoniac, is formed by adding muriatic acid to liquid ammonia, evaporating, etc. 6 cents per ounce. Muriate of soda, culinary salt, is procured by evaporating the water of the ocean. Muriate of strontia, procured by dissolving native carbonate of strontia in muriatic acid and evaporating. 75 cents per ounce. Muriate of lime, formed by evaporating a solution of marble in muriatic acid. Muriatic acid, marine acid, spirit of salt, is extracted from sea salt. 12 cents per ounce. Nitrate of ammonia, procured by dissolving carbonate of ammonia, common smelling salts, in nitric acid. 20 cents per ounce. Nitrate of potash, nitre, saltpeter, may be procured by adding nitric acid to a solution of subcarbonate of potash and crystallizing by evaporation. 3 cents per ounce. Nitrate of strontia, procured the same as muriate. 75 cents per ounce. Nitric acid, aquafortis, is obtained by distilling 2 parts of sulfuric acid together with 1 part of saltpeter. 12 cents per ounce. Nut galls are formed of the leaves of a species of oak. 6 cents per ounce. Olive oil, sweet oil. 3 cents per ounce. Oil of cinnamon, extracted from cinnamon by distillation. 75 cents per ounce. Oil of rosemary, procured also by distillation. 25 cents per ounce. Orange lead, a scarlet pigment similar to red lead. 3 cents per ounce. Oxide of manganese, a black powder consisting of a metal combined with oxygen. 10 cents per ounce. Phosphorus, a simple substance procured from bones. Its greatest peculiarity is extraordinary combustibility. 200 cents per ounce. Phosphuret of lime, a combination of lime and phosphorus, 200 cents per ounce. Plumbago, blacklead, a carburet of iron, 16 cents per pound. Potassium, the metallic base of potash, may be readily obtained from pearl ash by anyone who has a galvanic apparatus. Prussiate of iron, Prussian blue, may be formed by adding prussiate of potash to a solution of copperas, 25 cents per ounce. Prussiate of potash, a combination of potash and prussic acid, 50 cents per ounce. Pumice stone, 12 cents per pound. Red lead, minium, is obtained by melting lead in an open vessel and exposing it in that state to the action of the atmospheric air, 3 cents per ounce. Red ochre, Spanish brown, a native oxide of iron, 6 cents per pound. Rosin, the resinous part of turpentine, 6 cents per pound. Silver bronze, 50 cents per pennyweight. Silver leaf, 30 cents per book. Slip blue, wet blue, an aqueous preparation of Prussian blue, 30 cents per pound. Spirits of turpentine, oil of turpentine, is procured by distilling common or crude turpentine. The residuum is rosin, 12 cents per pennyweight. Subacetate of copper, verdigris, 3 cents per ounce. Subcarbonate of potash, pearl ash, potash refined by calcination, 12 cents per pound. Sulphate of copper, blue vitriol, Roman vitriol, 3 cents per ounce. Sulphate of iron, copperas, green vitriol, 6 cents per ounce. Sulphate of lime, plaster of Paris, alabaster, gypsum. Sulphate of zinc, white vitriol, 3 cents per ounce. Sulphur, brimstone, is generally found combined with ores of metals, 3 cents per ounce. Sulphuric acid, oil of vitriol, the condensed vapor of burning sulphur, 16 cents per ounce. Sulphuric ether, procured by distilling alcohol with sulphuric acid, 25 cents per ounce. Supercarbonate of potash, sal auratus, is formed by passing a current of carbonic acid gas through a solution of pearl ash, 3 cents per ounce. Supercarbonate of soda may be prepared in the same manner from the subcarbonate, 12 cents per ounce. Supertartrate of potash, cream of tartar, is found encrusted on the sides of casks in which wine has been kept, 4 cents per ounce. Tartaric acid procured from cream of tartar, 12 cents per ounce. Terra de sienna, an oxide of iron that becomes dark red by burning, 6 cents per ounce. Tin, grain or granulated tin, 12 cents per ounce. Tin foil, metallic tin rolled to thin laminas or sheets like paper, 12 cents per ounce. Turmeric, the root of a vegetable, 3 cents per ounce. Umber, a brown earth that becomes nearly black by burning, 3 cents per ounce. Venice turpentine, 6 cents per ounce. Vermilion, a sulphuret of mercury, is sometimes found native, but may be procured by grinding sulphur and mercury together and heating them first in an open vessel till the mixture takes a violet color, and afterward in a flask or matras, 12 cents per ounce. Whiting, Spanish white, refined, 12 cents per pound. Yellow ochre, spruce yellow, an oxide of iron, 12 cents per pound. Zinc, spelter, a metal of which with copper or brass is made, 3 cents per ounce. End of section 31. End of a select collection of valuable and curious arts and interesting experiments by unknown.